Hi, my name is Dave. Welcome to my epic Kusto Query Language KQL crash course. The point of this is to introduce you to Kusto or Kusto Query Language KQL. We're going to be demoing it here in the Azure Data Explorer today. This isn't a 100% coverage course on how every last corner of the language functions. My intention is just to get you to a place of reasonable fluency so you can start using it to profile the behavior of some system which is generating data in a store that you can query with KQL. So I think this probably shouldn't be your first exposure to programming, but I'm not going to stop you if you're an eager learner. So if you prefer a written form rather than a visual presentation, there is a write-up for this that I'm going to be publishing, and a link to that will be in the comments, in the description. So my background with KQL and also similar query languages is mostly in an investigative capacity, troubleshooting problems with telemetry. My aim is to be general enough in my approach, though, that this can be a suitable introduction for you, regardless of what your use case is with KQL. So my opinion with such query languages, maybe even programming languages in general, but especially with these types of query languages, I think it's healthiest to approach them as you typically would a role-playing game or RPG. In such games, there are different categories of skill sets, and usually you aim to level up all of the categories of skills at approximately the same rate for a balanced gameplay experience. So if I were to draft a list of such skill categories for KQL, I'd probably make it like this. These are comments in KQL, by the way. These are not real commands. I'm just writing comments in here for now. So I would probably write them like this. The first one would be, I would call it language recognition or manipulation. That's the first category. The second category of skills I would call table manipulation. KQL autocomplete is extremely powerful, even even in the comment section, I guess. The third category I would say is statistics. And the fourth one I would call domain knowledge. So this is like if you work for a fishing company, then this is going to be knowledge about the fishing business. Okay. So I'm going to try and keep this curriculum balanced across these first three skill set categories. In the real world, you don't want to neglect domain knowledge. That's important too. That's knowledge about the business meaning of the data sets that you're querying. That's going to be useful to you. But for today, we're going to focus on these three. I advise you to follow along in the Azure Data Explorer help clusters available at this URL. You can see there's all kinds of tables in here with test data for you to explore. So I think you should follow along because if you don't actually run these queries yourself, you might not see I'm not going to copy and paste the entire table for every query in the write-up for this. So I suggest, that you run these yourself so you can see how the tables are transformed when you're entering these queries. Some cases we won't use these tables. I'll have data that I provide that will, just kind of fake and put in here just for demonstrating particular scenarios that you might not find in these tables of test data. And so the general idea with this language, okay, if this is your first exposure to this language, it's like the general idea is it's transforming tables, okay? So the idea is you provide a pipeline of commands. Okay, command A, and actually you start with a table and you direct that table to a command. We'll call it command A. That command A, it's banging around in there with that table and it changes it, probably. Then it goes and produces the change table out the other end, and you pass that to another command. In each of these commands, typically, the operations you define in these commands, they're performed on each row in the table at that point in this pipeline before moving on to the next command until you finally have your final table, right? The final form of your table. So that's the general workflow that you're going to see here today. So the first thing that you have to learn is filtering data. That's the first step to success with KQL. It's about not grabbing the whole table, especially if the data that you're querying is absolutely massive in volume, and you'll find that can be true. Maybe in this help cluster, but especially out in the real world, there can be pretty massive data stores that are accessible to you with KQL. And if you grab the whole table, it's like, is your head really in the game? So try to think of yourself like a hunter. This is my little pep talk, okay? But try and think of yourself like a hunter, not one of those deep sea trawlers, okay, where you're grabbing like everything in the ocean at once. You're more like a detective that's hot on the heels of a demented serial killer. You're not like a band of hopeless traffic cops doing a dragnet, setting up roadblocks all over town, okay? So you gotta make sure you keep that mindset at the forefront always when you're dealing with this. So this problem of not grabbing the entire table at once, there's two approaches, okay? So the first approach is one based on a set of conditions regarding the content in the rows of the table. Okay, that's the first way to not grab the whole table, is based on that kind of set of conditions. The other one is not based on such a set of conditions, okay? So there's an important distinction there, and the first one that you should learn is actually the opposite order that I listed these, okay? That's this one, not based on such a set of conditions. So that's the first skill you should learn, is limiting the results of your search regardless of the nature of the table's data. So a common time that you might use that skill, it's not just if you're a beginner, but you're always going to need this because, for example, you're going to encounter tables that you haven't seen before. If you haven't seen a table before, you probably need to get a sense of what the records are like before writing more detailed queries. So you use this approach, and there are several ways to do it, but you use this approach just to get a sense of what's in the table. Another way, by the way, of doing this, let's go into sample logs, okay? By the way, so how this works over here is you just click on one. Now these tables should be accessible to you, okay? If you try and reference a table that's not in the section that you're in, that you have selected, then it might not work for you. So, for example, we're going to be here to start. So you might say, well, let's look at trace logs. I can get a sense of what's in the table just by clicking this button and seeing, well, look, it shows you the data types and the column names. That only tells you the data types, okay? It doesn't tell you the types of language that you're probably going to see in here and here, okay? So some analysis might be required. So before you go crazy and start doing things, you need to know, just get a general sense of what's in this table, you know? Familiarize yourself with it. So I call this content ignorant filtering. So the two commands we're going to talk about are, it's actually just one command. I think they're aliases of one another. Take or limit. So they're synonyms. They do the same thing. This is a command that I use the command. There's going to be two approaches I'm going to demonstrate. The other one is going to be using a function called rand. So these are the two approaches, this one and this one. These are the two approaches to not based on a set of conditions, that kind of filtering. I use this one more, but for completeness, I'll share this with you too. We'll get to that in a minute. So how do you take? What does that mean? It's like you just give it an integer, a number, and it returns to you that number of records from the table. That's it. So even if the table doesn't change in between subsequent runs of this command, so you run it once and the table hasn't changed and you run it again, it might not give you the same set of records each time you run it. So if I never used a particular table before and I just need a quick glance at what kind of things might be inside of it, I'm probably going to use this to return a small quantity of records to have a gander. Okay, so here we're going to use this trace logs table. Okay, so the first thing is you reference the name of the table. Then we use this pipe command. The pipe can go on the same line, but for that gets, you're going to have a whole list of these, and doing it all in one line gets old fast. And some people might be following along at home on their mobile devices. So actually, I'm going to try and zoom in here. Is it possible to zoom in? It is. So this might be better for people who are on their mobile devices. I'm going to close this too, okay? All right, so we're going to reference this table. And we're going to take 10. You can specify any number, but I'm just going to say 10, okay? So you see here, it gave us 10 records seemingly at random from the table. There you have it, okay? So if I specified 13, you'll see we get a few more. So it's really simple, and you can now do things to these records, and we'll get into that. So that's this approach, content ignorant filtering, part A, take or limit. The next way of doing it is with the rand function. So the rand function, let's say, like, you don't know this number, really. Let's say you need a slightly more relative way of grabbing a limited quantity of records from the table. So like you want to limit how much data you're grabbing, but you don't want to specify a literal number of rows. Instead, you want to specify like an approximate percentage of the records from the table. Okay, so that's where this one comes in. So the rand function, you can use it for many things actually, but what it really does is it returns a random or maybe pseudo-random number in the range of 0 to 1. So like a decimal, right? And let me just give you an example using the trace logs here. Okay. So, and we're going to say where rand, and I'm going to put a question mark here because we don't know yet. Okay. So, by the way, you see how this is highlighted? This command here is highlighted in blue. Not like that, but if I select it, right, you can see there's like a light blue background. That means that when I click the run button, this is going to be executed, not this one. Okay. You see how whichever section is highlighted in blue, where your cursor is, that's what gets executed when you tap the run button. So that's a convention in many KQL editors. So we'll get to what condition we put here in a moment. But so rand, so right here we have a random number between 0 and 1. This means less than. So we're going to give it a threshold. We're going to give it a number here. So what's going to happen is this where command is going to run once for each row in the table. Maybe not, I mean, don't be too literal about that because we don't necessarily know behind the scenes, the geniuses that made KQL, how they do things literally. But the meaning of what we're saying here is this gets executed once for each row in the table. And only if this condition after where, only if it's true, will any particular record be returned. So this is going to return a random number once for each record in the table. And so you understand what's going to happen, right? So we have to give it a threshold. So let's say that you, so basically it involves odds, right? I mean, if the number produced is less than the literal threshold that you provide, then and only then will it be included. So this strategy involves odds, so you would expect it to have some kind of margin of error. What that means is before you even do this, I would do the back of the envelope math first before you run such a query. So how do you do the back of the envelope math of how many rows are in a table. So this is how you do that. Okay, there's just a count thing. You can see it gives you a description here. This is just going to tell you how many records are in the table. Okay, so 158,000 some records. I'm sorry I can't zoom in here on the bottom, really. Guess I could zoom in a little bit here. I hope that's okay for the people at home. Okay, we're going to make the UI a little bit weird here. I just want to make sure that those people who are on different screens, maybe I can make this full screen too. Okay, so this tells us we have 158,000 records. And so let's say that you're like, okay, maybe I'd be okay with like, like 1.5 thousand or so records from the table. So that's like 1% of the records, right? So if we're going to play the odds, we're going to say 0.01. Okay, so this is going to say, only if the random number that's produced between 0 and 1 is less than 0.01, then include the record. So if our odds are correct, we should get about 1.5K records back. Okay, and you can see odds, there's some margin of error, but we got about 1,600 records. So this is how you can do like sampling, right? We didn't actually need all these, but thank you, Microsoft, for giving us this table for us to do this kind of math with. I hope that makes sense. So that has been this first thing, or this one right here, not based on the set of conditions. So the next thing, once you master this skill, now you can start grabbing records based on a set of conditions regarding the content that's actually in the rows of the table. That means the content in this column, or this column, or this column, or whatever. So I'm going to give you just a couple examples, all right, of how you can do that. So we have a sample of these here, right? So let's say we see, look at this component column. It has something called downloader. It has something called ingester, executor. Let's say we want to look at some records from this ingester, executor. I don't know what that is. That sounds like techno jargon to me, but we're going to use a where condition. It says where component. And I'm going to say starts with. Okay. So, and let's say we don't want to grab again the whole table, so let's take like 10 of these, all right? So we have 10 rows now where this component says ingester executor. Now, let's say maybe we want to see, could there maybe be other ingester executor rows in this table with the same client request ID? Because it looks like this is a duplicate here, right? 379. Let's try this one. Okay, maybe you can fly out down here and we'll just grab that. So you can specify multiple of these, all right? So I'm going to say where client request ID. In this case, I'm not going to say starts with, I'm just going to say equals. And we'll put that in there. And then we got to chain these together with an and. You can also use or, but in this case, we want and. We want it only the rows where this is true. Client request ID is equal to this, and the component column, we close that, is equal to ingester executor, and we want at most 10 of such records. So if this is easier for you to understand, if you just put limit, you can put limit instead. Okay, would you look at that? So actually we have quite a few of these. So in this command, again, just to reiterate, you're basically going to be using the where command to retrieve only the records in the table that meet a set of conditions that you specify. So if you've used languages like SQL before, you'll probably be somewhat familiar with this part. The thing that you have to be strictly careful of is, and I mean strictly careful, is avoiding the narrow set of situations where your where condition could inadvertently force a full table scan. So that means before we saw there were 158,000 records. Okay, sometimes there might be millions upon millions, hundreds of millions of records. You don't want it to go through and search and literally search every single, scan that entire table, right? Um, that's called a full table scan, and this is computer science, right? So you should always be considering how to avoid a linear search. In KQL, with the where command, there is one situation where you force it to do that full table scan, and that's the situation where you're comparing two columns to one another. So let's say where you would never do this with this table, but where you were comparing this column to this column instead of comparing this to this value and this to this value. Instead, you write a where condition where you're comparing two columns to each other. So the docs mention that this situation is one which can't use any indexes. If that confuses you, don't worry, but just, it's going to force a full table scan. So if you find yourself unable to avoid a situation like that, the advice given is to always place that where condition last in your sequence of where conditions, okay? So that it is scanning the smallest table size. So let me give you an example of what that means. This is not a good example with this table, but let's say our fictional example of comparing one column to another is for some reason you needed to compare the component column value to the level column value, okay? So, if you have to do this, then this should be last in your chain of commands, right? In your chain of conditions, right? After all of the other conditions. And that's so that by this point in your chain of conditions, it's this condition is, considering and scanning the smallest table size possible. This is a really niche situation that I'm referring to, but you're probably sharing these resources with other people. It bears to keep that in mind. Or you should keep that in mind. And so the real thing that you're going to concern yourself with far more often with where clauses in KQL was I just hinted at it, okay? And it's going to be putting your most restrictive filters as early as possible in the where chain. So this means if you have these, let me change this, let me control Z back to where we were before. I don't know about you, but if I was going to bet and put money on this, I would say probably there are more records with a component value of ingester executor than there are records with client request ID equal to this exactly. I don't have proof of that, and we're not going to go through proving that. But if I had to guess, that's a common sense guess that the ID probably there are fewer tables with fewer records in this table with this value than there are this one. So that means this is more restrictive. It tends to return fewer records. So this is the one that I'm going to put first in the chain, okay? So this is a kind of a common sense thing, but it's you may just not think of it, So that's why I'm telling you that. Just kind of do that kind of betting scenario when you're coming up with a chain of conditions where you're thinking which one will probably return less records. There are ways to investigate that too, and we'll get into that. But you should at least be considering that in your mind when you're thinking of how to order these things. So there are a lot of different string operators. Here we're comparing strings. There, of course, sometimes these columns contain numbers, and you can do number comparisons. That's like these two numbers are equal, or this number is less than or greater than this number. So that's easy for most people to understand, but definitely string comparison, like we're doing here, tends to have a lot more to it. So there is a site here in the Microsoft documentation showing you these string operators. Don't worry, this will be in the written documentation. These are all the ways that you can compare different strings, okay? So this is really good documentation. Spend some time on it and follow some of the links to see some of the examples, okay? My most commonly used ones are equals, starts with, and another one called has. all right? So in each of these has like a negative version too, which means like not equal to or does not start with or does not have. Um, and each of these also has a case sensitive and a case insensitive version. Where possible, you'll want to try to use case sensitive operators because they're more efficient, but it's not against federal law. You can use case insensitive operators, especially when you're in a first encounter with a table, you don't have good bearings with what's going on with the data. You just want to get a good handle on things first. You can start with case insensitive operators and then upgrade to you can start with case insensitive operators and then upgrade to case sensitive later on. Okay. So let's go through some examples of these operators on the trace logs table. Um, let's say trace logs where component starts with, but actually we're going to use the case sensitive version of starts with. I'm just going to say ingester, and I'm going to say component does not end with, case sensitive version of does not end with. I'm going to say executor. So let's not grab the whole table and let's let this run. So this is like a positive, I would call this like a positive case sensitive prefix filter. And this I would call like a negative case sensitive suffix filter. We're trying to find a few rows where the component column starts with this text, but ends with something besides this to see if that's even a thing. Oops, my mistake. I got to select this. There we go. So here we found a sample of rows where the component column contains values like ingester and gateway that fulfills these two conditions. So that's why we got these records. So there's a limit to prefix and suffix searching though. Sometimes you need a slightly more stateful approach to filtering. For that, KQL has a cool tool called matches regex. So I was just going to say use it mindfully because this is just a betting situation, but we don't know necessarily how they're implementing things behind the scenes. And with a lot of programming languages, with using regex, sometimes you tend to the trend is that regex is amazing. It's very expressive, and when you learn it, you start to find all sorts of situations where you can use it. But the problem is, there's a little bit of a performance cost to using this really cool tool sometimes. So, if you can avoid using it, I would say just use these other tools. But that's not a mathematical proof I'm giving you there. It's just a general advice. So basically, you're going to provide a regex pattern that that will tell you whether or not something matches, and that will be your where condition. And if you I'll explain how this pattern works. And you know what? I'm just going to preface this by saying, if this is way over your head with the regex, don't feel bad. Later on, we're going to get much more in depth with regex, and I'm going to give you like a full introduction to it. So just don't worry about that for now if it's way too complicated for you. So let's say you want to pull only the records where, let's consider the node name, right? Let's say you want only those records where the node name, it ends in a number between 700 and 999 inclusive. Okay, so this is possible to do with regex. So we could say where node matches. I'm not saying this is the most efficient thing in the world, but this is correct technically. So let me just type this out here, and then I will explain it afterwards. Make sure I have that right. Okay. I'm going to limit this to, let's be naughty and grab 25 for ourselves. Okay, let's try that. Hey, would you look at that? It worked. So the pattern, this is the regex pattern, okay? And I'm going to explain to you what it means in natural language. So it starts with this caret character that anchors it to the pattern to the beginning, and this is the dollar character anchors this pattern to the end. So that means this is fully anchored, okay? So this is the regex pattern that's fully anchored, which means that this pattern should describe the string from the beginning to the end. You're like, well, how else could it be? That means if these were missing, it means that this pattern could match something somewhere in between potentially without and then there could be other text like before or after, if that makes sense. Anyways, so this part means match, oops. This part right here, engine, means match the text engine exactly. This part right here, highlight carefully, this means 0 or more of the character 0, so 0 or more. Then it means exactly one character from the set of characters 7, 8, and 9. So 7 to 9 is a range of characters, 7, 8, and 9. So it's a set of characters, 7, 8, or 9. This means exactly one character from that set. So it could be a 7, an 8, or a 9. Okay. This means, so this part means exactly two of these. And this is any digit, 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So two characters, and each one can be any of those digits. All right, that describes what we're going for. So if you needed more complicated logic to determine the engine number than that even, and you didn't actually know the engine number you're looking for, then you might want to look into like extracting this number into its own column and to continue filtering that way. So that's a kind of a more advanced thing. We'll discuss similar situations later on. So let's go to a different set of logs. We're going to go to security logs. Let's go to outbound browsing. And you can see it's like, oh, I don't know this table anymore. That's what I mean. When you're in here, you have to have the right section selected. It's not going to recognize the tables. So here we're going to look for through the outbound browsing table. And let me just grab, before we go crazy, I'm going to just show you what these logs look like to give you a fighting chance. All right, so we have a URL. Okay, so what are we going to do? Pretend you're a security person. We're probably going to look at what URLs are they accessing, right? Contains, case sensitive. I like to think that, oops, vertically binds. I don't know what that is, but we're going to find out. Vertically binds. You see it has a warning for us. Has a high compute price. Use the has operator in cases instead. Again, I do prefer has, but this is one situation where one of the few situations I could find to demonstrate contains that I felt was appropriate. So let's take a look and see. Would you look at that? So what's the difference between has and contains? Uh, Contains is supposed to be about matching any substring, while has is supposed to be about matching KQL's interpretation of alphanumeric substrings. At least that's how I understood it. And in theory, that makes it sound like contains should be more powerful, right? And that might be true in theory, but in practice, I don't like this operator because I just find when I'm expecting it to match punctuation, it seems to behave counterintuitively. So honestly, what I do, I stick to prefix and suffix searching. We're using has until I need to make the full jump to match his regex. Okay, so that's why, to be honest with you, in the real world, when I'm using this tool, I don't use this that often. But don't let that stop you. So another thing that we're going to discuss is matching based on set membership. So just as a reminder, in case you forgot, a set is a list with no duplicates. Membership is something in that set, okay? Just in case you're a little rusty on that. So what this means is in your where condition, you want to accept a record if the value in a particular column is a member of a particular set or list that you have in mind. So there's a few ways to do this. And the first way is the simplest. It's where you provide in your query text a literal list of values, such as an array of strings or a list of strings, indicating that a record may be accepted if the value in the column you specify is somewhere within that list of strings. So let me give you an example. First, we're going to go to process events. This is one of the available tables in this help security logs section. I'm going to take 100 just so you can see. Okay, you can see what these logs look like. So we want to filter this a little bit. First, let's do not based on set membership. We're going to say, because you notice there's like a parent process name and a process name. Maybe we want to check the parent process name. Let's say we don't want sd.exe or these other ones, but we want cmd.exe. But I'm noticing that cmd.exe has uppercase and lowercase variants. So I'm going to say where parent process name is equal to, case insensitively equal to, and that's with the little tilde character on here. If this were case sensitive, then it would have to be double equal, but with the tilde, that makes it case insensitive. So we want records where that is true. Okay, great. So we have solved that problem. And now we want to filter based, we want to allow only a few, but more than one, right? So you could do this with an or condition. So you could say like where process name is equal to this, or it's equal to this. But my way that I'm going to show you how to do this, because we're demonstrating set membership, I'm going to say in, case insensitive in, by the way. So case insensitive in is with the tilde. All right, I'm going to start the set here. Oops. And I write it vertically. You don't have to write it vertically, right? You could write this all in one line. I just do this for the people who may be following along at home on like a phone or something. Chrome.exe will allow, and then the other one that will allow is excel.exe. Okay, so we want them where we want records from this process events table where parent process name is like CMD, uppercase or lowercase, or one of these, and the process name is one of these two process names, uppercase or lowercase, or any weird combination. And we're going to limit ourselves to 100 of those rows. Okay, there you see. So that's the simplest way of matching based on set membership. You would call this a static approach because these are provided literally in your code. It's a static list. It's not changing unless you change the text of your query. So you can do this more dynamically, where you don't have to hard code the values into your query. With the dynamic approach, you might have your list populated, that's this list right here, where it's populated with a table from another query. So then you might call that a subquery. The subquery produces a table, and then you check if the value in the column that you specify is in that table produced by the subquery. So I would love to demonstrate that for you, but before we get there, I have to say at this point, without teaching you some other essential KQL tools, I've explored these help clusters, and the examples of that in this table are going to be a bit contrived. So instead, we're going to shift gears now, and we're going to talk about two other topics for a little while before returning to this. Okay. So the next part is producing statistical summaries. Okay. Don't be intimidated. I'm not a stats whiz, but I do enjoy statistics. Okay, it's kind of counterintuitive, right? I'm going to teach you just enough to cause problems for people with statistics. Okay, I'm not going to teach you enough where you're going to be splitting the atom or putting people on the moon probably, but I'm going to teach you enough to maybe just enough to like bully people. Okay, so by now you've probably realized through all these queries I took you through, it's cool that we know how to filter and pare down these records, right? The sets of records, but we're still humans. We're not robots, are we? So the records, as humans, we have to read them one by one. We got to read these things, these lines. So that's time consuming. Our time is valuable, and also as awesome as we are, we're prone to fallacious thinking. We fall prey to anecdotes. So now that you have a set of records, you want to comprehend them, right? You want to derive some meaning out of these things. It's supposed to mean something, right? So this is where you start using KQL as a tool to understand things in a more statistically significant way. This is much faster and more accurate than just reading through a load of logs or records or log files manually. Just the only caveat is that you have to have a sense of how to do it. So the main way that you do this in KQL is with a command called summarize. In other languages, it could be called other things like stats or something. So the first thing you need for the summarize command after you filtered your record set that you're feeding it is what's called an aggregation function. So an aggregation function is typically given a table and sometimes a specific column from that table in particular, and somehow it aggregates the values for you. So I'm going to introduce the summarize command for you by taking you through some of these aggregation functions. So the first one that we're going to go into is count. Okay? So let's shift gears here away from help security logs and let's go to sample metrics. Oh, look at that. Anyways, so sample metrics. There's a table called transformed server metrics. And we want, okay, again, I should give you a fighting chance and show you some records from this table. Okay, so we want this metric type right here. So you can see there's like values and all kinds of stuff in here. Before we go too crazy with this, I don't know if there's other things in this table, but we only want SQL Server performance, okay? Because on this particular fictional day, we're bullying the SQL team. So where metric type equals SQL Server performance, all right? So we only want those. We don't care about other server performance. We're only concerned with criticizing the SQL servers. So now what we need to do is maybe we want to know like how many SQL Server performance rows are in this table. You know what I mean? Because we don't care how many records are in this table as a whole. We only care how many SQL Server performance records do you have. So how do you summarize that? Well, you can summarize that by saying count. Okay, this is the count. So summarize and count. Oops, there we go. Got to select the query. There you go. So that is a big number, 259.3 million. So I should be careful with the queries that I run, right? So when you run this, just to rehash, you get a table. This does give you a table, but it just has one column called, in this case, it gives you like a default name, count underscore, and that single value. Actually, this is the same value that I had in my notes when I originally was doing this. That's really interesting. It never changes. So if you wanted to like name this column something else, I'm just going to show you how to do that real quick. Let's say you wanted to name it that, right? See? So the other way to use this count function is with what's called a by clause. So a by clause and just before we get into it, I just want to warn you, this is where you need to start thinking in terms, if you haven't already, you need to start thinking in terms of each column's cardinality. Let me put that in here. Start thinking in terms of each column's cardinality. And Google that if you need to. But cardinality, it's a measure of how many unique elements a list contains. This is important because with a by clause, the count function is going to run once for each unique value contained in the column that you specify. So let me just copy this and show you. So if I say by, let's go back up here actually. I don't know about you, but I legitimately forgot what the other column names are in here. I have it in my notes, but I didn't want egg on my face. Let me take 20 of these and check it out again. Yeah, DB name. So you see there's like DB name in here. So you want to know a count of how many SQL Server performance records by DB name. So let me, so you're going to say by DB name. This is the column name. So this is saying, so here, first of all, let's give a natural language explanation of this one step at a time in the pipeline. So grab this table, grab only records from this table where the metric type column is equal to this exactly. Then take that list of records and count them, but run this counting function once for each unique value in this DB name column. So this is a unique value, Azure SQL DB2. There might be other ones in here, who knows? But we're going to produce a separate count for each DB name. Okay, you kind of understand what I mean? So it looks like we have two of them, and they have a suspiciously similar amount of records. Maybe that's not so suspicious, but you can actually specify more than one column name in the by clause. All right, which means, let me give you another one. There's one called metric type. And actually, that doesn't make any sense because we're already, let me just go down here. We're going to go, we're going to filter on a different thing. We're going to say, I happen to have this in my notes. There's a VM called ADX VM. Let me just make sure. Yeah, there is. So we want where the host is equal to that. And we want to say summarize the count of records in this table by metric type and DB name. So this means every unique combination of values in these two columns, right? So what's a unique combination of these two values? SQL Server Performance and Azure SQL DB2. That's a unique combination. There may not actually be any other in this record set that I pulled, but we're going to find out. So let me run this and maybe that'll make it more clear what I'm talking about. Okay. So every unique combination. So this is a unique combination, right? Azure SQL DB2, SQL Server Performance. You see there's other ones, SQL Server Performance, ADX, SQL DB. There's SQL Server Wait Stats in each of these. You see what I mean? Each combination of these is going to have its own count value produced. So at this point, you might want to preemptively assess the cardinality of a particular column. Okay, now you're starting to see how confusing it might get, right? With how many records there are, you're like, I got to be careful. So in order to assess the cardinality of a column, that's the next aggregation function. It's called dcount, short for distinct count. It's a distinct counting function. There's another one called count underscore distinct, but I usually just use this one. Instead of giving you the overall number of records in general in the table that's passed to it, it gives you the number of unique values contained in the column you specify. Or if it's really difficult, I think it might just estimate. So for this, we're going to go to Contoso Sales. And we're going to take a look at the customers table. So let's look at customers and see what kind of stuff we got in here. Look at that, customers in this table. Region country names. So let's say we want to know how many distinct region country names are in here. We want to kind of see, like, you know, Contoso, how many unique countries do they do business in? It'd be good to know. Okay, so here we're saying summarize. This is that assignment thing that I told you. We're just naming the output column name, right? So if I didn't do this, if I deleted this and just said decount region country name, it's going to give us a default table name. Maybe I should demo that. So, okay, so here it's telling us 6, and you can see it just comes up with like a default table name. Let me, oops, how do I go back? Control Z, there we go. So run this, and there we're renaming the column to something that we want it to be called unique country names. So this function, it sounds simple, but it's a key tool for assessing the cardinality of data in tables, because there are many times where you're very much interested in avoiding producing way too many combinations of things. And believe me, that's easier to do than it sounds. So next aggregation function we're going to use is sum, not to be confused with count. The functions are not the same. Sum is when you have a column that contains numerical values and you want to produce the sum of those numbers. That's very different from counting the records in a table. So let's say you had a table with a single column and 3 records, and each value was the same value of 1 million. The count function would give you a value of 3, whereas the sum function would give you a value of 3 million. So it's important to remember the difference. So we're going to stay in Contoso sales here. And I'm going to show you a couple of different sums. So if you remember, actually, we're going to go to a different table. So let's take a look at this table. So we have a sales amount here and a total cost. Let's do a little bit of accounting, okay? So let's say, oops, we need a summarize command. We want to know, summarize total sales revenue, sum of sales amount, right? I'm not an accounting major, so if you're an accountant, feel free to ridicule me. Total sales cost is going to be total cost, all right? So we're going to produce these two figures. Those are pretty big. Those are some pretty big numbers. Total sales cost is like $377 million. I'm assuming this is dollars, and the total sales revenue is like 685 million. So this is a big business. Maybe worth getting involved with these people. So using this too, until we get our calculator out, we're pretty close to understanding how much profit Contoso sales business has made. And soon enough, we'll discuss that too. But for now, let's split these sums out by product key, because if you remember in this table, there's a product key, right? So we want to produce these two figures once for each unique value in the product key column. So remember how we used our by clause before? We're going to say by product key. This will tell us which are the best and which are the worst. Let's see, total sales revenue, total sales cost. So total sales revenue, this is the highest one. Boy, there's a loser in here. Based on this, to me, it's clear which product key Contoso needs to stop selling immediately. Can you figure it out? If not, we'll revisit the question in the section on adding columns. We're going to get there soon. So next, we're going to talk about the average function. This is perhaps the most used and also most abused function in statistics. People use the average function as though it is some kind of holistic summary of a list of numbers. It can contribute to giving you a greater understanding of a list of numbers if you take an average of them, compared to, for example, if you're just scanning through the list and taking a look at them. But a proper summary of a set of numbers will also consider other statistical aggregation functions, and that's really a discussion that you should have with a statistics nerd that really wants to lecture you about it. I'm not going to belabor the point, but you should definitely consider that. So for now, I'm just going to show you how to produce an average. We'll stay in Contoso sales and we'll look at the sales table. And let's say we want to know what's the average value of the sales amount column for each country. So, looks like the French are pretty smart shoppers, right? They don't spend a lot compared to the United States. We're big spenders. I wonder if that was intentional. That's really interesting. So that's an average, right? And we all remember, how do you calculate an average? It's like calculating the sum and then dividing it by the count, I think. Anyways, so moving on, we're going to talk about max and min. Believe it or not, these are statistical aggregation functions. They give you the biggest and smallest figures, respectively, in a column of numbers. So let's look at the sales table, and we'll see what the smallest and largest sales are. At this point, I doubt this is a real sales data and real security data that's in these tables. It's probably faked, right? Fake test data, but it's really interesting to see. Um, okay, so minimum sales amount is 0 in every country. The maximum is, um, actually, maybe Australia has the smarter shoppers. That's kind of interesting too, isn't it? So that's minimum and maximum. Finally, we are going to talk about percentile and percentiles, okay? So if you have a list of numbers, and again, this is a thing where like if you're doing something that's mission critical, putting the man on the moon, you're in the wrong place, okay? I'm just teaching you how to bully people with statistics just enough to get by, to profile stuff. If you really want to take it further with statistics, you should go to a legitimate source, okay? I'm not saying that I'm illegitimate. I have success professionally with statistics, but I am saying you should go to a proper authority. So I'm just going to tell you my impression. Percentile, if you ask for the nth percentile, generally speaking, it's kind of like asking for the number from a list where n% of the other values in that list are less than that number. Okay, so that's the general idea. But like I said, if you're curing cancer, maybe you should double check. So I'm going to give you an example of asking for the 95th percentile. And we're going to juxtapose the 95th percentile with the figures produced by the average and maximum functions for comparison. Okay, so we're going to grab the average first. We'll put the percentile in the middle. I'll get back to the arguments that it takes. That's the part in the parentheses. Sales amount. Okay, so we're going to have the average and the max. Now in here, we do put sales amount, but we have to give it n, right? The nth percentile that we want. In this case, we're looking at 95. So let me run that. So if you understand how that works, then maybe you're ready for the percentiles function. Before I give you that example, just you can kind of imagine these on a timeline. The average here may, I got to be really careful how I say this because it's really easy to get the wrong impression of what statistical functions really mean. But this is the 95th, the maximum you expect to be greater than the 95th percentile, right? Which is the case. And you would expect the average to be lower than the 95th percentile too. So if you understand, like I said, if you understand how that works, then you can use the percentiles plural function. All that is like you want multiple percentiles calculated in one shot instead of just one. Okay, so it's if you're lazy and don't like typing a lot, is basically what it is. So percentiles, sales amount, and then we're going to give it a bunch of them. Want the 1th, the 1st percentile, the 5th, the 50th, 95th, and 99. There you go. See? And you can see they get progressively bigger. Okay? So one more aggregation function called std. The name of this function is short for standard deviation. The number produced by this function, it's a measure of the spread or dispersal of a list of numbers. So let me give you, I'm going to open up MS Paint. I'm going to go old school on this one, okay? So we have, okay, that's bad. Can I increase the size? Okay, so we have points out here in space, right? Each of these has like a different magnitude, okay? So the number produced by the standard deviation is going to tell you how spread out are these points, or are these numbers from each other. Another way it is sometimes explained is to say, and I'm just saying this is how it's been explained, it doesn't mean this is literally the formula, okay? But it's kind of like if you were to calculate on average how far each data point is from the mean. So let's say if you were to take an average of all of these points, each of them is a number, probably the average is going to be like right there. I'm just guessing. Okay. So this, let me maybe change colors. So this point here has this distance from the mean. So this one has this distance from the mean. This one has this distance from the mean, etc. So if you take all of these distances from the mean and take the average, that's not literally the formula for standard deviation, but if it's hard for you to understand what a standard deviation is, that's basically what it's telling you. It's telling you how spread out these numbers are. So if you were to take, let me choose another one. We're going to say blue. So if you take the standard deviation of the blue dashes, and then you take the standard deviation of the black dots, the standard deviation of the black dots is going to be probably a greater number because they're more spread out. The standard deviation of the blue dots are probably going to be smaller. Okay, so it's just so as with all these functions, there are caveats and pros and cons. But suffice it to say, a bigger standard deviation typically means a list of numbers is more spread out. A smaller one typically means the opposite. So I'm going to give you an example just to compare the average to the standard deviation. So here's the standard deviation of sales amount, and here's the average. Okay. So we'll see each of these. They're different numbers. This is an indicator of how spread out these values are in the sales amount column. This is an indicator of the average, right? So I'm just going to give you, there are some limitations to this function, standard deviation. And I just want to point these out because I've ran into this professionally and it's important for you to keep in mind if you're going to bother to use it. So as numbers get bigger, their average can increase. And when that happens, so can the standard deviation. However, in some more objective sense, that doesn't necessarily mean the numbers are more spread out. So we'll talk more about that later. That's the first caveat. The second thing is standard deviation might not be able to tell you if a list of numbers is like skewed or more spread out on one side of the average or one side of the distribution and not the other. So like, if you're using the standard deviation to see if there's like suddenly there's some kind of like erratic distribution in a set of numbers where there wasn't like an hour ago, you know, depending on what you're doing, you may not actually care if it's erratic on the low side, right? Maybe you want to know if they're more spread out on the high end, okay? So it's hard to explain if you haven't found yourself in that kind of a situation. But to detect such a thing, one could argue you might be better off looking at percentiles, okay? So if you run around sharing with people standard deviations, I'm just going to warn you, sooner or later, someone is going to look at you and give you a percentile instead. That's probably what's going to happen to you. Okay, so I'm going to pause there and I'm going to pick up the recording again later. Thank you so much. Continuing. So next, I'd like to talk about some simple table manipulations. Up until now, you've been filtering rows from the table, and that's not the only way that you can prune the size of your tables. We can also add and remove columns. So we're going to talk about adding columns first. Why you would add columns to your table. Sometimes the ones that come with your table aren't enough, so you need to add another one. And you do that by extending the table. The name of the command is extend. It adds a new column with the name you specify, and it sets the value to the result of a KQL expression. The expression can take quite a few forms, so we'll look at some examples. We're going to stay, I guess I'll label this. So we're going to reference the customers table, and let's take a look at some records. You can see we have some customer records here. Let's say we want to give these customers a nickname. So we can use extend. Here's the new field name, and we set it equal to the result of an expression. The simplest kind of expression is probably just a static value, like a string, for instance. It's hard-coded into our query. Okay. So let's maybe scroll over, and we can see we have a nickname on here. So a couple things. First of all, when you're doing this, you're not permanently adding a new column to the actual table in the data store. So just because I did this does not mean this customers table now in the help cluster now has a column permanently stored in it with this value. That's when you do this, you're extending the in-memory table that we're working with in our query here. So at least that's true of the kind of KQL that we're working with. In this example that I gave, you might think this is kind of useless. Who would need the same literal value to be provided to every record? Now, it's true, these fictional data sets can make it difficult to imagine, but there are real situations where you might need that. But usually, it's true, the extend command, it's used a little bit more dynamically. So earlier, we had a query to calculate standard deviation and average of sales amounts. So now we're going to use the extend command to add a new field based on the values that are contained in these. So I'm going to label these first of all. I'm going to call them S and A. All right. So we have these. Now we're going to use extend. This is also just to show that you can extend a summary statistics table that's produced. Okay, you can extend any table. I'm going to call this coefficient variation. And we're going to set this to S divided by A. Okay, so coefficient of variation, it's like the ratio of the standard deviation to the mean. It overcomes the first weakness of the standard deviation discussed earlier. So it can give a more objective perspective of data spread. In cases where the ratio exceeds 1, that means that S is greater than A. So you might explain that as meaning the average distance of the data points from their mean is even greater in magnitude than the mean itself. So in certain situations, that can be an indicator of significant variation in a data set. So let's say you want to round these numbers a bit to make them easier to look at. You can also use expressions to do that. So we're going to use a rounding function to make these easier to look at because these decimal values go pretty far. We don't necessarily care about that. So I'm going to use this round function. As you can see, it has a number and a precision. And what's the default precision? 0? We don't want necessarily 0. Let's say 2 for the precision. Oops. And let's, we can reassign. This is to show that you can reassign values to existing names, like S is an already existing column in your table. You can reassign values to it with the round command. Sorry. I mean with the extend command. Geez, I don't know why it's autocomplete. Sometimes autocompleting is a little strange. Okay, so let's see how this affects our results. That's easier to read, in my opinion, though less precise. So with this new power that we have in hand to extend our tables, we're going to revisit an earlier query where we were taking sums of sales amount and sales cost by product key. Now let's extend this and we're going to create a column. Let me just bring this one up again so you can refresh your memory. So remember, we were just showing total sales revenue, total sales cost. Well, now we can extend and create another column for total sales profit, because in my primitive view of accounting, profit is the same thing as, let me give ourselves some extra space, is equal to revenue minus cost. Okay, that's my primitive view of accounting. And when I run this, I see for product key 176, there's a loss of over 37.5 million on this product key. So in my opinion, Contoso should stop selling this product key, right? It's really the only one that's in the negative, and it's significantly negative. It's a fictional data set, though. Okay, moving on. There are what else can you do with? We're kind of doing just like mathematics here and assigning static values. A lot of times, though, you need to create a new field, which is the strings or values contained in other columns spliced onto one another, end to end. That's called concatenation. Okay, so an example, a simple example of concatenation, um, you know, would be if you have these two strings and you concatenate these, that will produce this string. That's concatenation. It might be hard to imagine why you would need to do this, but I promise if you use KQL, eventually you will need to do this. One common scenario in which you'll need to do this is when you're building time series tables and graphs, but we'll discuss that use case later. For now, trust me that you're going to need to know how to concatenate multiple fields. Ideally, there are some tools out there in the world that don't let you do that, but trust me, not every process in the world is collaborative and cooperative. So sometimes you're going to have to get down and dirty with the values in your table columns like this. So the function that we use to accomplish this when we're extending our table is called strcat. And actually it's called this in some other languages too. So we're going to change to security logs. I'm going to close this old tab here that I had open so I don't get confused. Let's go to security logs. And in security logs, I'm going to show you file creation events. Okay, so you can see some file creation events here. What do we got on the right side of this table? Yeah, you can see all kinds of information. Timestamp, host name. This is a hash of the file that's created, presumably. The path in the file system where it's created, and then in case it's convenient to you, just the leaf name, just the simple file name, and then the size, presumably in bytes. So one thing that I'm noticing about this is we have host names, and these paths are Windows file system paths, right? How do we know this? Well, sometimes it says Windows, but the other dead giveaway is these have a drive letter, which is associated in a colon followed by, the backslash style of file system path separators. So we can presume these are Windows systems. So in Windows, there's a convention with file systems. Let me take this as an example. Okay, I'll just type it out. So 9n12 dash machine is the host name, and the path is, let's see here, it's C colon Windows system32 where.exe. In Windows, in Windows World, there's a network file sharing convention or system where if it's enabled on a network, the host name, you can access the file systems of files on other hosts in the network from one host. So you could be like, if these two machines are in the same network and they have the network file sharing enabled, then from this machine, using in the File Explorer or other tools like scripting languages, or shell scripting, you can access the file system paths on this machine if you know the proper syntax. So the syntax for doing that, this is the convention. So it's going to be the host name, then the drive letter, followed by a $ instead of a colon, and then the rest of the path. So in this case, it would look like this: 9n12 machine \C $, I'm just going to copy this. And so if these were accessible on the same network, you could go on this machine, and in the file browser, you could go to this path, all right, to access a file from this machine, assuming that you have the correct permissions. So why am I sharing you this? Well, there's a lot of things in this table, and maybe if you're a security person, you need to do some auditing. So you don't want to go by hand and type this out and do this transformation, right? But you could do this in KQL. This is a fictional example. Maybe you rarely would ever need to do this, but this is an example that allows us to demonstrate the strcat function. So we're going to create a new field that has this value in it, okay? We'll call it network file path. And we're going to use the strcat function. Just for those following along on their mobile devices, I'm going to make the arguments to this function vertical instead of listed on the same line. So the first thing that we're going to do is we're going to do backslashes. Now, I'm not actually sure if the I'm not actually sure so this is a different, up until now I've been sharing, strings like this, just with double quotes. So if you have an @ symbol before that syntax, it's a different type of string. So it just means that escaping works differently in it. So with ordinary KQL strings delimited by double quotes, I believe backslashes are an escape character, and I just didn't trust myself to count correctly. So I'm taking advantage of this situation to demonstrate this type of string to you. So the @ version of KQL strings, how it works is the only backslashes are just a literal character in them, is basically where I'm going with this. The only caveat is that if you need double quotes somewhere in your string, if you need like a single double quote, you see it gives you an error, because that's what you need to escape in this style of string. You need to escape double quotes by providing another one. So a pair of double quotes in this style of string means one double quote. So this is giving an error here because it's missing a closing double quote. Okay, if that's confusing to you, this is a convention that's shared by CSV file format. And we're not even going to need double quotes because there shouldn't be quote characters in paths, I believe. So I just wanted to show that, but that's why I'm using the @ style, okay? Because I happen to know the only thing we really need to escape in these strings is the double quotes, and we're not going to need them. So I just don't want to deal with figuring out if we need to escape these backslashes or not. Okay, so that's a convenient way. So that's the first thing. We need the double slashes because it's going to be like this piece right here. Then we need the host name. So however many, this is a variadic function, so you can just provide however many arguments you want to concatenate, however many column names, you know. So host name, and actually we'll give the, yeah, see, it's like a variadic thing. That means as many arguments as you want. So, okay, after that we need another slash. That's this part. Then we need a drive letter. So how I'm going to cope with this is I'm just going to give the path, but I'm going to run a replace string function to, because you'll notice the path is a little bit different. It's going to be the exact same path as we have down here. The only difference is this colon needs to be a $sign instead. So what I'm going to do is run this replace string function. And the replace string function, you give it a string, in this case the path column. You give it the character or the string that you want to replace, and then, oops, I don't know what's going on here. I thought I typed the path. This autocomplete is not my favorite, to be honest with you. Okay, so then the character in this string that you want to, the string within this string, or the substring, you could say, within the string that you want to replace, that's the colon, and then the substring that you want to replace it with, which is a $sign. All right. So that's it for replacing the string. Now I'm going to show you what does it look like now. You can see it seems to have created properly formed network file paths. If you're confused about what the difference is between using replace string or not using replace string, just do it this way, okay? Just instead of doing replace string, just compare the output of these two commands, okay? This one with the incorrectly formed file paths with the colon, and this with the $sign in them. All right, see the difference? That's what replace string does. We're just replacing the colon. So now we're going to do some summarizing of the values in this column. I'm thinking there might be some repeats in here, but I'm not sure. So I want to count them by network file path, and I'm worried that list too might be even too large. So I'm just going to say use another command called top 100 by count. So I know that this command is going to produce a table with a column called count underscore, the default name of the column. And I want the top 100 rows from this table by count. So that means the biggest, from this table, it's going to grab, well, you know what? Let me just, I'm afraid to run this without this on here, but this is going to be the biggest. This is top. If top is hard for you to understand, think of it in terms of the word biggest. The biggest or the most common 100 network file paths is basically what this is. So let's see here. Looks like there's only one repeat, which is kind of interesting in this whole thing. Is that really true? There's only one repeat in this whole table. That's fascinating. So this could be useful to you. I don't know why, but we learned a couple of things along the way here with this. Um, so next thing. Now, at this point, you're like, actually, there was a lot of stuff in this table that we didn't need. Okay, and even in this table, we don't really need these counts, right? Maybe we only want the most common ones, which, actually that's kind of fictional, right? Because most of these are just we only see each of these like one time anyways. But let's just say, at some point you're doing so much stuff in your pipeline commands, you get the sense that there's a lot of data in the table that you don't need anymore in your in-memory table. So it can feel cumbersome to keep all that in the table through multiple stages in your query pipeline just because. So if you want to optimize for performance in memory, get in the habit of removing the unneeded columns. So one way of doing this is to provide a list of columns which you'd like to retain. I like this option the most because it feels the most explicit. And you do this with a command called project. So I'm just going to tack this onto the end, and you're going to see this is like an allow list of columns from the input table. So this is going to be the input table to the project command. The project command has an allow list of columns, and it's going to produce a table that only has those columns you specified. If you were more, you could specify more, but then what would be the point of calling this? In this case, I'm just going to provide one column, and that's going to be our new table. So there we have just a list of network file paths. You can do other things with this command. You can use this command to rename columns that you're keeping. If so, let's look at, for example, we were doing standard deviations and averages earlier. Standard, yeah, like this one. And actually, I think we need to go back to Contoso sales for this. So remember, we were calculating these. Well, you could just rename these. So let's actually, before we do this, let's see, what is the, now we have the old column names. Let's rename them with the project command. We'll say this, we're going to go real short and just say, there we go, like that. And we'll just call it the mean. There you go. So we're going to rename these columns to that. We lost some of the meaning, so just be careful with this because you don't want to confuse yourself or other people. But sometimes you need to do this if there's a later command that's maybe expecting the columns to have a certain name or something. So we can actually make other changes in the scope of this project command. The assignments that we're doing here, actually it can be just any KQL expression. So that means in the same file swoop, we can make other changes like rounding the figures or even adding new columns that didn't exist before. So you can also use this as a way to extend. So remember we were doing rounding? Let's do some rounding right now. So in this case, we could round this to two decimal places. We could do the same thing. I'm just going to copy this actually, and we'll replace this. There we go. And we can add another one. We can create the CV, the coefficient of variation, right off the bat. And we'll round it to two decimal places. See? There are other features of this project command for you to experiment with. And I mean other variants of this command, like project away. For example, being able to select which columns to keep or get rid of with like a wildcard search. I don't use these as often, but you can look into them now that you understand the concept of this one. You can easily look up the other functions and start using those. Okay, next up is we're going to be talking about, drum roll please, regex. Some of you are like, oh my gosh, I'm feeling nauseous now. So regex is a really core tool, make no mistake. I think everybody, not everybody, but a lot of people, even outside of the programming world, in IT world, a lot of people still work with tables, right? Spreadsheets and Excel, pretty omnipresent tools. A lot of people, even outside of the white collar world, encounter tables on a regular basis. So the fact that we're working with tables, it may not be that foreign to people. But in my experience, the concept of regex and regular expressions just as foundational of a tool as far as our civilization is concerned. But people outside of the programming world are much less commonly, interfacing with this tool. But make no mistakes, it's a really foundational tool. It's not just a KQL thing. There's a lot of different regex engines, but they all kind of have a similar approach to solving a problem of recognizing regular languages. So it has to do with the notion of a regular language in formal language theory. Cliff's notes of that is in formal language theory, we try to classify languages by how complex of a machine or program, but we classify the languages by how complex of a machine is required to recognize that language. So what does recognizing a language mean? Well, it means like if I present the machine with a string, that machine can tell me if that string belongs to a particular language. So regex is supposed to be limited to the core, the most simplistic kind of language in formal language theory, which is a regular language. But this limitation, don't let that bother you. It's really a powerful tool. So there's other types of languages and other types of automata, so to speak, but we're going to focus on regex. So when you write a regex pattern, what you're doing is you're declaring a logical pattern to which any input text or sequence of characters will or will not adhere. The point of the regex is to tell you if the input text adheres to that pattern or not, and also, in some cases, to deliver to you any subsequences of characters from the input text which you asked it to remember for you. So I'm going to discuss the components of these logical patterns. While we won't cover 100% of the logical components available to you in regex patterns, we're going to cover enough of the core elements to get you up and running. Now, before we get started, I would say that if this small regex presentation that I'm going to give is the only thing that you need to understand and fully set out on your own to start using regex, if it's the only thing that you require, you're just going to watch it once and be done, and you are like totally empowered, you know it, you have it down pat, you're in the true minority and you should consider applying to NASA because in my experience, it takes a little bit for people to absorb this concept. So, take your time with it if you need to. I'm going to give like 3 different ways of practicing regex, 3 simple setups for you to use. The first one I'm not going to show you. I'm just going to tell you, at the time that I'm recording this, AI tools like ChatGPT are all the rage. This tool is available for free. These tools are available for free on mobile phones. You can go to ChatGPT and ask it to provide you with regex practice problems, and you can get really specific about what you want to practice, and you can ask it to grade your response, and it will gladly do so. I recommend that you do that if you're looking for creative things to practice on. There are 2 other ways of practicing regex that I will demonstrate. But first, we're going to just stay inside of Notepad here because it's a text-based tool. And before we get started writing any programs with this, I just want to explain in the text editor here. So the first thing that we're going to talk about are what are called character classes. They're just a syntax for you to define a logical set of characters. Remember, a set is a list with no repeats. So a character class is a syntax that allows you to define a logical set of characters. To make it even simpler to understand, consider that underneath it all, a character to a computer is on some level just a number. So what does that mean? Okay, if you're familiar with ASCII, look at that. So you see, here's a list of ASCII characters. These are like the characters on the right side. There's digits in here, letters, all kinds of characters, and each one has some type of number. In fact, they're giving you multiple types of number: decimal, hexadecimal, octal, etc. So I'm just saying that's what underneath it all to a computer, it's characters are just numbers. So a character class is typically demarcated on the left and right side by square brackets. Okay? So between the square brackets, you define the characters which are part of the set. So this is a set of lowercase vowels. If you provided only that character class, this right here, as a regex pattern, it would require that the input text has at least one character somewhere, which is one of these vowels. So I'm going to demonstrate that too, and this is going to be the second thing that you can look at. There's a tool called regexer. I'm not affiliated with these people in any way, but I just want to show you this site, regexer, regexr.com. So you can see when I provide this character class, it matches all the lowercase vowels. All the matches are in blue, are highlighted in blue here in this input text. So if I provided this regex pattern, this is what it would match. Typically, but not always, you differentiate between letter case. There are ways to do case insensitive, but I'm just going to show you. So here, now it's a set of lowercase and uppercase vowels. So for example, we have the uppercase E. You're not limited to only letters. You can do, let me close this and zoom in. You're not limited to letters. Can I close this too? Geez, I can. Okay, that's great. So I guess maybe we'll just stay in here instead of Notepad. So this is one way you can test. So you're not limited to only letters. You can do numbers too. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So actually there's no, you put some random stuff in here. So you can see it's matching numbers or digits and also periods and commas. So this syntax could be kind of cumbersome because, first of all, regex doesn't have variables in the way that many Turing-complete programming languages do. And it's like you're going to type out every character that you want to match. I mean, that would seem to limit the usefulness of this. But remember how we said that characters are just numbers. So that means you can use range syntax to specify a range of characters rather than list them all manually. So instead of listing A, B, C, all the way through Z, you can just do A through Z like this. And here's uppercase letters. And maybe we want digits too. That's better. Only 9 characters to specify 3 character ranges: lowercase a through lowercase z, uppercase a through uppercase z, and 0 through 9. That's a set of 62 characters if I can do my math right, and we only needed 9 characters in here to specify that. This syntax does have some side effects though. For instance, it does mean that if you need to support matching a literal hyphen character in your set, you need to use a slightly unusual syntax where it is at the end. What that means is, let me change this so you can see we have a couple places now where there's a literal hyphen character. If I delete this, it doesn't match those literal hyphen characters, even though we have hyphens in here, because these hyphens are being used to specify these ranges. If you want to match the hyphens, you need to place it at the end of the set. It's slightly unusual syntax, but. So if we did this, this is the set of all lowercase letters and a hyphen. Sometimes this can become too complicated or difficult to work around. When that happens, you can work around it by taking advantage of the fact that most regex flavors allow you to specify character ranges in the form of numbers, like hexadecimal values or other schemes. That's outside the scope of this introduction, though. But I do have two final tricks to help you with your character classes. So first of all, sometimes it would be cumbersome to calculate the character ranges to accept, when really you're more concerned about not allowing a particular character. These are the cases where you're saying, I don't care, just accept any character as long as it's not one of these few characters. There's a syntax for this kind of negated character class, and it's starting with a caret character. So this accepts any character except lowercase letters and hyphens. You can see no lowercase letters are matched, no hyphens are matched. Also, there are shorthands for many commonly used character classes built into most regex flavors, and at this point, you have to really look at what regex flavor you're using. We're not going to spend too much longer in this regexer thing because we have two engines to choose from, JavaScript and PCRE. We are actually using yet a different regex flavor called RE2. And so there may be some syntactic differences, and I'm trying in this course to teach you this flavor that's compatible with KQL, right? So we're going to depart from that. But here on this page, here are some conventional, let's see here, character classes. Take some time going through this. Vim characters, there's all kinds of, this is like a glossary of how to do this. But I have them written down, so I'm going to just explain them in the pad here. So there are some conventional character classes. They're like shorthand for many commonly used character classes, so you don't have to type them out over and over again. So one is a dot. This means any character. The dot means like literally any character. Commonly, it does not match new line characters. So that can vary based on the regex engine, but that's pretty common. This, a backslash and a lowercase d, this is a set of digits. So this is like 0 through 9. Oops. This is a convention that means like 0 through 9. This is an uppercase D means like a negated character set of like this. It's like anything except digits. A lowercase s, this is the set of white space characters. Okay? And an uppercase S, you guessed it, any characters except white space characters. So these are common shorthands for commonly used character classes. There are more. You can look them up depending on which engine you're using. The latter two, these two, have given rise to a common conventional character class that overcomes the limitation of this, where this does not necessarily match new line characters. If you really need to match any character, even if it's a new line or not, or any weird character, you can use this, the set of all white space characters and the set of any character except white space characters. That means, logically, we are specifying any character, including new line characters. So you can keep that convention in mind. So now you know how to specify at least one character in regex. Now we're going to talk about concatenation and quantifiers. Concatenation, similar to what we were discussing earlier, concatenation is a technique that allows you to define more complex logical patterns that span more than just one character. You accomplish this by specifying character classes one after another. So this I can demonstrate in regexer. So if we just put these back to back and list character classes one after the other, three in a row, are we, what's going on here? No match, huh? What if I delete this? Oh, okay, that's why, because there was no match. Sometimes I don't even trust my own pattern. But this, so this demonstrates it, right? So this matches a sequence of two characters where each character is one of the lowercase letters A, B, or C. So you can see why this matches because B is in this one and A is one of these. So that's why we didn't get ABC three times because apparently there is no such sequence of characters in this text. So this will match all kinds of sequences, BA, AC, CA. They don't have to be the same though, and commonly they won't be. So let's say you want to match a word where all letters are lowercase except the first letter, which could be lower or uppercase. So that we can do like this. So here's, sorry, I said all the rest are all lowercase, didn't I? I'm breaking my own rules as I make them. So this is my name. Okay, so this matches my name whether the first letter is lowercase or uppercase, and the other ones have to be lowercase though. All right. So for instances where a character class is only comprised of one character and the character in question isn't a special one as far as regex syntax is concerned, you can do away with the square brackets. So that means you don't need square brackets around these since these character classes only have one character each. All right, so this is the same thing as what we just had, where each of these three letters has brackets around it. What if the sequence of characters you want to match is extremely long? For instance, you want to match a sequence of your character class which is like 100 in length. That would seem to be a lot to type out. So for that, we would instead use a quantifier. A quantifier is a suffix given to your character class which indicates how many characters to match. Let's say you wanted to match a string. I'm going to go back to, not that it doesn't work in here, but this is getting a little abstract and we don't have any text in here that's going to match it. So I'm just going to demonstrate this in here. So let's say you want to match a string of length 100 characters where each character is from the following set of characters: X, lowercase or uppercase, O, lowercase or uppercase. And you want, it has to be of length 100 characters exactly. Well, here's the character class. And instead of copying and pasting this character class 100 times, you can give it a suffix like this, which specifies how many of these to match. That will match exactly 100 characters from that set. You're not that restricted though. So what if you would accept anything between like 75 and 200 characters in length? You can do a range with this syntax too. So the range is going to be, we said 75 to 200. It'll be like that. So this will match any sequence of X's or O's, uppercase or lowercase, between 75 and 200 characters in length. Because quantifiers are so handy, there are a few commonly used shorthand alternatives to the curly bracket syntax. So this means this is the equivalent of 0, comma. 0, comma, in this case, we're not providing an upper bound like we did here. So that means 0 to infinity. So this means 0 or more characters from the preceding character class. So that means, you know, If you went like this, that would mean like 0 or more X's or O's. Okay. A plus. This is the equivalent of 1 comma, which means 1 or more characters from the preceding character class. And then a question mark. This is the equivalent of 0 comma 1, which means 0 or 1 character from the preceding character class. It means it's optional, but at most you can only have 1. All of these quantifiers, which with ranges shown here, are known as greedy quantifiers. So that means since they have a range of valid lengths, if given an option to match more or less characters from the character class, they'll try to match as many as possible up to the limit. In the cases of X's and O's, this means if you had 100 X's and O's and you passed it to you tried to match it with this, I mean, this greedy quantifier wouldn't stop matching once it got to 75 characters. It would keep matching all the way to 100 characters. So the opposite is a lazy quantifier, which tries to match as few as possible. So to turn any of the quantifiers, including this one, into a lazy, you put a question mark at the end. So contrary to what I said about this one means if you gave it a sequence of 100 X's and O's, this lazy quantifier would still match, but it would stop matching once it got to 75 characters. So we're actually going to test this out in a little while. But first, we need to discuss a few more logical operations. So next we're going to talk about anchors. Anchors are also known as atomic zero width assertions. Zero width because they don't consume any characters. An assertion because they impose a requirement upon the pattern. So if you visualize the current location of the regex as it's analyzing an input text as a cursor, then it's saying that at that specific point in the pattern, the cursor should occupy a particular kind of location. If that still seems abstract, let me give you a few examples. Okay, these three patterns mean different things. This one we saw already, I believe. It indicates that the input text must have a sequence of 3 characters somewhere inside of it where each character is from this set, A, B, and C. The second one means the opposite. It means a sequence of 3 characters somewhere inside of it where each character in that sequence is a member of the set which is comprised of anything except for A, B, and C. The third one, which is similar in syntax, but it is different. It starts with a caret character outside of the character class. It indicates that the input string must start with such a sequence of 3 characters, where each character is from this set. So the caret is the starting anchor. It means the first character in the regex pattern. I'm sorry, this must be the first character in the regex pattern if it is used. It means that this sequence that you're looking for, unlike here, this sequence could be anywhere within, this for example, A, B, C. I mean, if we have, okay, we have this. I mean, this one can match, like, it could match this one, for instance, right? Actually, this is a bad example because, let me change some of these here. It could match any of these subsequences, right? This one means that this sequence of 3 such characters has to be at the beginning. So none of these fit this pattern, any of these in here that I was showing you. These don't fit the pattern because these aren't at the start of the string. This one is. Even if we change this to like CAB, this is still at the start of the string. All right. Now, what is like this one? Just to rehash, this is this sequence right here fits this one, right? What if we had this? Getting tricky on you. This string does not fit that, but if we change this to like a K, now this fits that pattern. Actually, it doesn't because that's a good question. It starts with a sequence of any, yeah, so all three of these have to be something else. So I guess if this was like an R and this was an S, now it would fit this pattern. All right. So I admonish you to not um, forget the difference between this and this. It's very important to understand the difference. It's commonly confused. I see engineers confuse it, and you should not forget the difference because this is a pretty common syntax for regex. There's another anchor to ensure matches must abut the end of an input sequence, and that's a $sign. So if we do ABC dollar, the $sign, just like this one must be at the beginning of the regex pattern, this one must be at the end of the regex pattern, and it means that this sequence of three characters in this set must be at the end of the string. So when you use the starting and the ending anchor in the same regex pattern, this regex pattern is said to be fully anchored. It describes this input string in its entirety from beginning to end. This only matches a few different strings: ABC, AAA, BBB, CCC, CAB. I mean, I'm not going to list all of them, but for sure, this is a string that is only of length 3, and all 3 of the characters are from this set. All right. There are other anchors, but I'll leave those for you to experiment with. Non-capturing groups. So these allow you to specify many logical patterns that would otherwise be tedious or impossible. I'm not really sure on that. You should ask someone that's a formal language theorist. But because these groups are non-capturing, they can be used even in regex patterns which aren't designed to extract text. So if that last sentence confused you, don't worry, we'll discuss capturing groups later. One powerful capability of non-capturing groups is the ability to apply quantifiers to whole sequences of character classes. So before I show you such a pattern, I'm going to develop a setup in the KQL workspace that allows us to test out some of these abstract language ideas without requiring any specific kind of data in the test tables. Okay, we're going to create like a fake data table that's just temporary here in memory. And you can use this setup in the Azure Data Explorer to test these ideas out. Okay? All right, so this is the same thing as basically, these other tables. It's just temporary, right? And we can put whatever values we want in it. Now we can pipe it to commands. So we're going to say where data matches regex, and in the string here is where you specify your regex pattern. So I'm going to type this regex pattern out, and I'll explain it. So this is going to be a fully anchored regex pattern. So I'm going to just put these in here right away. We know it's going to be a fully anchored pattern. These strings I want to describe from beginning to end, front to back. We're going to start with a non-capturing group, and it's going to have a quantifier. So the non-capturing group, it's a pair of parentheses that start with a question mark and a colon, and then you put your pattern in here. And actually, I'm going to put a letter here. We're going to start with an A. I want the string to start with an A. And our non-capturing group, I want it to be the sequence of characters B, C. You could put these in character class brackets if you want. You don't have to though. And I want this to be at most, from like 1 to 3. Okay, so just to review, the non-capturing group is demarcated at the start by an opening parenthesis, a question mark, and a colon, and at the end by the closing parenthesis. Everything between these boundaries is part of the group. In this case, the sequence uppercase B, uppercase C. A quantifier is applied to this entire group. It means between 1 and 3 repetitions of the sequence BC. And finally, this pattern has a starting and an ending anchor, and a literal A here. So we're going to run this. So when you run this, you'll see the fourth string where expects match is false. It does not appear in the resulting table because it does not fit. This string does not fit the pattern, the logical pattern that we defined. This is because it has 4 repetitions of BC. We have an upper bound of 3, at most 3 repetitions. Okay, so I'm going to actually, this is like a cooking show. I do have this stuff kind of canned and tested already, so I'm just going to paste this in here for the sake of time so you don't have to watch me type. So here's another one, and we're going to change this table, all right? So first of all, I'm going to change this pattern to allow 1 or more, and this is to demonstrate nesting. So I'm going to have a B in here, and then another capturing group. Which is like a C. Okay, so this pattern means something like an A followed by 1 or more of this sequence, which is a single B followed by 1 or more C. So you can see the expects match false, which does not fit this pattern, did not make it into the results. So next we're going to talk about alternation. Alternation is a technique that allows you to specify alternative options for a regex to try matching. It can be applied at a top level within a regex pattern, or it can be applied within groups. So I urge you caution at this juncture, if you find yourself tempted to use alternation, and even quantifiers in some situations, it can become confusing to understand how many times a regex will do certain things owing to features like backtracking. So spend time researching the rules and constraints you're working with so you can avoid catastrophic backtracking. Here's one example of alternation. So I'm going to grab the data and I'll write out the pattern. So this is going to demonstrate alternation. This is going to be another fully anchored pattern. And I'm going to change this outer group. We're going to allow a B or an uppercase B. Then we're going to have a nested capturing group, which we need 1 or more of. In this nested capturing group, we're going to allow a lowercase sequence of CD or an uppercase sequence of CD. This is the alternation. This is the alternative option. We're giving the regex an alternative option within this nested capturing group. Okay? So 1 or more of this or this. So let's kind of try and explain in natural language once again what this is. It means like a lowercase a followed by 1 or more of, this sequence, which is a B, lowercase or uppercase, followed by 1 or more of this kind of sequence. Okay, so let's run this and you'll see, I'm going to select that. So you can see all of our trues made it into the table and the falses did not, because the falses, somehow they violate the constraints that we've given them. So I urge you to use this setup to test your understanding of these logical regex elements. Once you understand why some of these are true and some of these are false, then at long last you're ready to talk about capturing groups. Okay, these were non-capturing groups. We're going to talk about capturing groups next. So these allow your regex to remember subsequences of text that are matched by the pattern. And afterwards, that text is delivered to you and you can store it in new columns in your table. This is a very powerful feature of KQL's flavor of regex. It allows you to use KQL to compose your own parsing routines for the weird custom file formats you might encounter in the wild. Using this tool, no longer will the cardinality of the data be obscured and obfuscated within the Baroque file formats and logging formats that contain it. And you'll find yourself performing valid statistical analysis just where your peers least suspect it. So, this is an exciting moment. If you are ready for this, you're about to develop a superpower. So let's talk about how to use them. Capturing groups come in two categories, basically. They can be named or unnamed. The syntax for unnamed is easiest. It's just a pair of parentheses. So we're going to use it with the extract function next. And the extract function requires these arguments. It requires the pattern. It requires an index number referring to which value you want the function to return. We're going to provide 1 indicating the first captured value rather than 0, which is the entire match string. If that's confusing to you, I will explain that in a moment. And finally, the original string field to which we are applying the regex pattern. So let's go to the security logs, which is going to be where some of the interesting example data is going to be. I'm going to show you the employees table. Let's grab some of these. Look at that. Now we have an email address in here. So we're going to only consider the email addresses, okay? There we go, we have email addresses now. So what we want is to create a column which is just the prefix of the email address before the @ symbol. And we want that in its own column. I don't know why you would want to do that, but this is a good example. So we're going to call it email prefix, even though there's probably a better word for it already, but that's what I'm going to call it because I'm some kind of weird language nerd, I guess. So this is going to be the regex pattern on this line. We're going to need to specify 1, and then the field that we want the regex pattern to apply to. And now the regex pattern, there are many ways that we could do this, but we want this to be not necessarily fully anchored, but I'm just going to describe it from the start. So we're going to anchor this to the start. Capturing group is just a plain pair of parentheses. And we know after the captured sequence, we don't want to capture the @ symbol, okay, in the center of the email. So we're going to put that after the capturing group on the outside of it. And how would you describe this part of it? So don't take this literally, but if this were my first encounter and I don't remember off the top of my head the rules with email addresses, I'm just going to say a negated capturing group is a lot easier. We know that this part it can't contain an @ symbol. We know that. So I'm just going to use a negated character class, one or more of any character except for an @ symbol. All right? So let's run this. And there you have it. The email prefix. So let's go through this again. This regex means starting at the beginning of the string, match and capture a sequence of length 1 or more of any character except for an @ followed by an @ and don't capture that final @ So you're like, what is the difference between if we had put a 0 here? I'm just going to demo that real quick. If you had put a 0 here, here's what you're going to get. All right? The 0 is going to give you the entire match, whether or not it's a part of the capturing group. So that's why we get the trailing @. The one means, just the part that's in the capturing group, parentheses. So you can actually, I'll just show you the syntax for a named capturing group. Okay, I'm not a fan of named capturing groups in KQL, but in other engines, it's just personal preference. I'm just going to call this prefix, okay? And you don't actually have to change anything else, and it's going to work just as fine. But this is the syntax. This is the name of the named capturing group. I'm not going to go any further with the name capturing groups. I don't find it that interesting. So let's revisit an earlier example. Remember when we were matching a sequence of 75 to 100, or sorry, 200 X's and O's, uppercase and lowercase, and we came up with this lazy match example. So let's prove this, that it will only capture 75 characters even if there are more valid characters available. So I'm going to, yeah, I'm just going to provide a data table that I already have typed out. I don't want to count again. So first we're going to need I'm actually gonna just to make just, it'll be easy for us to see the original length, just as like a proof, I guess. Original length, there's this function strlen, and that's gonna tell us the length of the input. Okay, so there's the length. We can see that it's 80. And now let's see how much it extracts. We'll call that the extracted length. Okay, now I'm going to use the strlen again. We're not actually going to bother displaying the captured portion because I just don't care, but we're going to okay, so in here, we'll put the pattern there, the one and the column name. So we're going to extract the results of the regex pattern, which I had in the notepad, the lazy pattern. Put that in here. So this is the lazy pattern, and actually, let's turn this, we need to turn this into a capturing group, right? So I'm going to anchor this as well, and just put the parentheses around this. Okay. So this pattern is anchored to the beginning, so it means starting at the beginning, match between 75 and 200 X's or O's lazily. So the question is, after we extract that from the string, and we force that output to be a string for this strlen function, what is the length of that extracted substring? Is it going to be the full 80 characters that are available, or is it going to stop at 75? You can see it truly is lazy. It stops at 75. The greedy version, you'll see it just goes to 80. So this is the difference between regex eagerness and laziness. Sometimes you want your regex pattern to extract more than one value by using multiple capturing groups. This is permissible, but you have to change the function to extract all. So I'm going to go back to employees here, and we're going to modify this. So we're going to call this email parts now. And now we can add something on here. We'll make it a fully anchored pattern that will match any character, 0 or more, to the end of the string. And then let's see what the table looks like. That's interesting. That's not what oh yeah, that's right, because I broke my own rule. You gotta use extract all. And when you use extract all, you don't need to specify this, and I'll show you why. Because it's giving you these this nested array system, okay? Well, more on how the nested array thing works in a minute, but obviously you want to extract these into their own column. So you do that with the extend command. Now we can get the email prefix by referencing email parts, and we're going to reference, I'll explain how this works with referencing the So we'll call that, actually, maybe that, yeah, suffix. It's a domain, so I'll call that properly, and this is one. And then we don't need the parts anymore, so we'll use project away to specify you can get rid of the email parts column. Okay, so now we have Deborah West over here and the domain over here that involve labs. So the the result from extract all is an array containing another array with the captured values. Hence why we're using multiple array accessors. That's what these are. These are array accessors telling you the position within the array or list to grab the values. So this is the outer array that's returned. And then within the outer array, the first value and then the second value, because arrays are zero indexed. See, this is where I say maybe this is best for this not to be your first programming language, because in computer science, most programming languages, arrays are zero indexed. That's something you should know. But so does it seem kind of weird though that there's nested arrays it's returned? It's like, why does it do that? Well, the reason is, if you recall, groups may be nested, right? We did that earlier with non-capturing groups. So that's why it returns these nested arrays, because when extracting multiple things with capturing groups, if there's nested capturing groups, the return value also needs to be in a nested or nestable format. So that's why you have to use this weird syntax. But you can add and subtract the lines from this query to understand what, for instance, you can delete this and then you can see, well, why are we doing this? You can see what email parts is. It's an outer array and an inner array. Okay, so the outer array, the 0th index of the outer array, there's only one entry in the outer array, which is the inner array itself. And then the inner array accessor, 0 for Deborah West and 1 for involvelabs.com. All right, so that's how it works. This is my intro to regex. It was a really fast, blazing intro to regex. If you got all of that just on the first try, I commend you. But if you haven't, I've given you tools that allow you to practice these things, right? I'm giving you 3 tools: regexer, this setup in Azure Data Explorer for you to use fake data tables, and finally, you can even use ChatGPT to practice. So, continuing, table joins. Well, there's a lot to say about table joining, and we're not going to go through everything because it would balloon this conversation. The best summary I can give is it's like if you applied all the things that you can do with a Venn diagram to tables. And how can you do that? Well, it's based on multiple tables, each having a column containing some of the same values. And before I show this, I just want to show you. This is what I mean by a Venn diagram. And if you look up a Venn diagram, table join, here you go. You'll see all kinds of diagrams. I don't vouch for any particular one, but surely if you take this approach when you're confused about table joins, you will get there. And there is a page in the Microsoft documentation that actually gives you the join operator that we're using in a diagram. So this is actually exactly the joins that are available with the KQL join command. And this goes through and gives you an explanation. So in my opinion, if I were to contrast this to regex, right, we said that some people, or a lot of people, don't necessarily get it down pat their first day they're exposed to it. Table joins is kind of different. Table joins, I think most people get the concept pretty early. That's not a problem. The issue is maybe spotting the use cases out in the real world where you can actually use them. So let's go through some examples. We're going to do a similar thing. I'm going to develop a setup here in the KQL Explorer, the Data Explorer, so that you can practice. So let's go to Contoso Sales. Go to Sales Table. Take 100. So these are some sales records. Now I'm going to show you the products table. Okay, because presumably we're selling products, right? So the products table has records of products, and there's a product key column here. And look, we have a product key column in here. So we want to join some of the information from this table and add it onto this table. And what does that mean? It means like the columns from this table, each of the records in this table will have the data that's in this table appended onto it. You'll see what I mean. So that's what we use the join command for. We're going to use an inner join. You specify the name of the table, and then you say on and which column, and it has to be the same name column in each table. And here we go. So now the tables are joined. And if you go over here, you can see, oh look, we have the records of all of the information from the table so that you can have a little bit more context to the sales, each sale that's made. And maybe you want to get rid of product key 1 because you notice there's the original product key column and then kind of this duplicate auto-generated one. Maybe you don't need the duplicate one, you can project that away. So this is one of the simplest kind of joins that you can do. Use poof and you get extra columns. It's really easy. A common scenario is like if you want to retrieve records from one table, call it table A, but you only want those records which are referenced, such as by an ID, by records in another table, call it table B. So maybe that seems abstract. I'm going to go over to security logs and we're going to do a little bit more complicated of an example. So in security logs, we have authentication events table. I'm going to take 500. I think we were looking through these earlier. We actually only need a few of these columns. So I'm going to project. We'll need the timestamp, maybe, probably. The host name, definitely we want. SRC, IP, username, and the result. The other details we don't care about. Let's see what that gets us. There we go. It's a smaller table. Now we want the not successful ones. So I'm going to say where result is not equal to. I don't know if I did it not equal to so far, but this is the not equal to operator in KQL for string comparison. Successful login. All right, that pared down our set to 294 records. These are all failed now. All right, now this is where we're going to join. And what kind of a join are we going to do? So we're going to do an inner join. On which table? We'll leave that to be determined. and it's I have to give away part of this. It's gonna be on the username column. Okay, we want to get information on these users from another table. So where can we get the username, the information on the users? Well, we can get that from the employees table. So let me show you some of those records. You can see we have name, email address, username, etc. We might not need all of these though. So instead of referencing, I think for this you could reference just employees like we did before, but you can also modify the table that you're joining on with like a table expression, I believe it's called. So this means you just put like another query in here. So here what we're going to do is just something simple. We're just going to project the original employees table and only take a few fields like username, name, IP address, email address, and role. All right. So we're going to do that. There we go. We have those columns now. And maybe we project away the duplicate username column. I wish there was a flag on the joining command to automatically do this. Maybe there isn't. I just don't know about it. Okay, so that's good. Now what I want to do is I want to count these. I want to summarize this because it's like, it's a lot of records to go through. It's 294. You're like, that's not that many. Well, in IT, it makes you lazy, and that's a lot to go through. So we're going to use the summarize command. And how are we going to count these? What unique column combination do we really want to count these by? I mean, I want every unique combination of username, IP address. That'll let us know if sometimes users are trying to log in from different addresses. Email address and role. Let's try that. There we go. And I'm going to use the sort command. You can sort with the column header, but you can also use the sort command too. Sort by count descending. Okay, so if that was too fast, I'm just going to go through and give like a natural language explanation of this. We're taking a sample of logs from the authentication events table. We're getting rid of some unneeded columns by projecting. Then we're filtering out all the successful logins, so we're left with only failed login events. Then the join starts. We're doing an inner join, which, do I still have that up? That's this one. That's the true intersection of the tables. What does that mean? Well, we're joining on this column, right? So these values are in each table, right? This column in one table is going to be one of the circles in the Venn diagram, and this column in the other table is going to be one of the circles in the Venn diagram. An inner join, because it's a true intersection, means the name has to be in both columns. So that means if this happened to pull a record from the authentication events table that had a username that's not in the employees table, that record is not going to be in the resulting table. Also, if this command pulls employee usernames that are not in this set from the authentication events that we sampled, then they're not going to be joined onto the table that we're producing. Okay. So basically, we're providing a subquery to fetch a set of results from the employees table, and the column which is shared in both tables is the username column. I'm not trying to repeat myself too much, I just want to make sure you understand. So after we fetch the employees, we specify on username to indicate we're joining the two tables on the values in that column. And if you're confused still, you can cut the query off right at this point in the pipeline to see the result before continuing. So we have additional fields attached to our failed login events indicating, for example, the role of the user that failed to log in. And then we're doing some summarizing and sorting to figure out who from our sample of 500 events was the worst offender as far as failed logins. So when I ran this, this is the top heavy hitter. I mean, granted, it seems pretty similar to some of the other ones, but maybe in this situation, if you were a security person, you know, the top few of these would be flagged because it's like, hey, what's going on? I'm just kidding. I'm not a security professional. But you get the idea. So this was the inner join. This is like I said, the intersecting parts of the two tables when you're considering that column that has values in both tables. If you're familiar with SQL, you're obviously you've heard of this before. This will be like, you know, a foreign key column or something like that. So just to help you understand the difference between an inner join and the other types of joins that are available, you can use the following setup to explore the difference in KQL. So we're going to create two fake data tables, named data tables. And you can change these columns if you want. You'll see this is a really nice setup. Kidding. Okay. Humans 1, QE, int null, 2, Dewey 4, 3, Louis 5. These are the humans. All right, let animals. You probably see where I'm going with this, but this is very flexible. Okay, these are our two tables. And we're going to set up a command to join these tables. So we're going to grab the humans table and we're going to do an inner join just to start. On pet ID, obviously. Now you'll notice this table doesn't actually have a pet ID, so how do we cope with that? Well, like I said, can be a real query in here. So we're going to take the animals table and we're going to project. And using project, we're going to rename the ID column to pet ID so that it fulfills the requirements of the join operation we're trying to do. And we'll say pet name equals name and species will leave. All right, let's run this. There you go. So not all of our records from the humans table made it into the results. Huey is missing because he doesn't have a pet. Also, Bruiser, the cat, did not make it into our results because Bruiser does not have a human owner. So let's now, using this setup, we can just change the kind of join just to see the difference. Let's see what a left outer join does. Well, with left outer, you can see it gives you the record now from the humans table that does not have an associated record in the other table. That's Huey. This is an important difference because sometimes it can make or break the logic of your query if you're doing joins. Sometimes you do need to not dispose of the records in the original table that are, or the left table that are um, without a companion from the table being joined. Um, so it can be kind of counterintuitive, but let me state it explicitly before moving on. The nature of joining is that the process has the potential to filter records out of both tables before producing the final result table. How and when exactly this filtering happens is dictated by the type of join that you choose. So there's, like I said, in that link that I showed earlier, there's quite a few to try. I would say to try all of them out, I will run a few so you can see. You can pause on any of these if you really want. I don't even know what all these mean quite off the top of my head. All right. So here you can see what this one is. This one is anything from the left table. That's the humans table that doesn't have something. All right. So this is kind of a query operator in a way. And I'm not saying that you necessarily, I mean, a filtering operator, like I said, right? And I'm not saying that it's always the most efficient way of filtering records, but anyways, here we go. This is a full outer join. And I don't think I'm gonna go through the rest, but go through that article and try out all of the different ones so you can see all the different things that you can do. My proposal is that Huey and Bruiser, that they sync up. I think that's a match um, made in heaven. Can you say that? I think that's cheesy, but that's clearly a rescue situation or something. I think they should sync up. All right. So earlier, moving on, now we're going to talk about time series. So not transformed server metrics. Okay, earlier I introduced you to the summarize command for calculating statistics based on your table columns. So if you play around with the summarize command enough, you'll eventually find it's easy to mislead yourself. If you take averages over a very large number of values in a column, it might seem to conceal the amount of variation contained in that column. That's just an example. Take the minimum and maximum functions. They might seem meaningless almost for everything except the smallest of tables or really specific use cases. So these kinds of problems, if not overcome, can easily get in the way of your analysis and hamper its accuracy and incisiveness. This is why Santa Claus invented the time series. For those of us for whom one or two averages are not enough, he said, hey, why not calculate a separate average for each day of the year? That way, when Santa is considering a child's naughtiness, he can easily separate any particularly naughty outlier days from the rest, the kind of excessively naughty days which might otherwise screw a child's average. So that's what a time series is really about. Instead of calculating a stats function like average, maximum, or minimum, or any of the others once or twice, you first bin all the values in the table into separate bins of particular length and time. 1 second, 1 minute, 1 hour, 6 hours, 5 days, etc. And then you calculate that function once for each bin of time across a larger span of time. 1 day, 1 week, 1 month, 1 year, etc. I'm just going to give in the comments here an example. Let's say the overall time span of records that you pull are 1 week. All right. And you want a time series over that week. Well, maybe you're going to do, 12 hour, or let's do 24 hour. That's probably easy. 24-hour bins. And you're going to be calculating averages. Okay. So this means you're going to have a Sunday average, a Monday average, Tuesday average, all the way to a Saturday average. You're going to have a series of these. And the records in this table, continuing with this specific example that I'm giving here, each record might have like a timestamp that's like this. Timestamping, I'm just going to give a few example timestamps. You know, one might be like Monday, 7:13 and 26 seconds a.m. Another might be Wednesday, 1:34:15 a.m., etc. So instead of doing that, instead of calculating an average for each unique value of this timestamp, I mean that's gonna not get you very far because the cardinality of this timestamp column is such that there's probably a lot of unique values if you're recording time to second level granularity. So you go through and you're gonna rewrite these timestamps so they're going to become like this. Binned timestamp examples, you're just going to rewrite everything that has a timestamp somewhere on Monday. You're going to rewrite that to say, okay, Monday. Everything on Wednesday is going to say Wednesday. And maybe not even Monday. You might do it in terms of the order of the days of the week. Instead of Monday, you might say, well, 0, 1 for those that are on Monday, 0, 2 for Tuesday, etc. So that's what the time series is about. And I hope that binning process makes sense. Let's look at an example. We'll go back to are we still in the authentication area? Yeah, we're still in the security logs. So I'm going to give you, let's take some of these, oh, not that many. So authentication events, we had these before. We want where, once again, result is not equal to successful login. And all right, so I'm gonna do, well, let's you already know what these look like, right? So I'm gonna say get schema. This is gonna tell us, pardon me, this is gonna tell us the data type of each column. Okay, so you can see in this the timestamp is a string. So for the function that we're going to use for calculating time series, it needs to be a proper date data type. Say that 10 times fast. So I'm just going to change this so that timestamp is equal to a call to this toDateTime function, and I'm going to pass this in. Now when I run this, you're going to see that the timestamp column is no longer a string. Now it is system date time. We need that. Now we can bin these values. So this is the old way that I showed you. This is the summary statistics. Okay, so we see 294. But we want to bin these, remember? So now we're going to produce a separate count for each bin produced by this bin command. And how many bin values will it produce? Well, in that sense, you need to know in advance what's the period of time that you're querying. We don't, and I'm just going to run this anyways. Well, there we have it. 59 bins it came up with. And you can see, because we chose a bin span of 1 minute, each of these is 1 minute granularity. Now we can render this into a graph. I'm going to render this into a time chart. And there you have it. You get 2 tabs here. So we are looking for results that are not successful. In this case, the type of the timestamp field was a string instead of datetime type, so we converted accordingly to make that field compatible with the binning. The summarize command, it's a lot like the previous runs I showed you, except now the by clause contains, instead of a solo column name, a call to that bin function, into which we pass the name of the timestamp column and the bin size. And then we render it as a time chart. So you'll see a graph drawn in one tab with time on the x-axis and quantity on the y-axis. Honestly, I usually call this a time chart. If you call it a time series, it always felt like calling an attorney Esquire. It's technically correct, but some folks might assume you're a tryhard. So time charts are an important tool for your anomaly hunting arsenal, and you can use any of the stats functions with them: average, minimum, maximum, etc. So you can produce a separate time series column for each distinct value in a particular column. This I would urge you to be cautious with. This is where it's kind of serious how I say, well, make sure you have a good handle on the unique number of values in each column or the cardinality of the data, because if you don't, you can kind of overload things here. But let's give an example of this. So first, we're going to produce a list of the top 10 failed users in the authentication events table, where now you're pros at this. It's almost like I'm teaching you how to be a security person. It's funny, where result is not successful login. And extend times. I think I could probably just copy my other query, but that's okay. I'll rewrite it. To date time, timestamp. Okay, and then next we want to summarize count, not binning it though. We just want to do a flat summary. Okay, and let's run this to see what we have. Actually, I'm going to have to get rid of this. I'm going to cut that out, and then we'll put it back in when we are ready to move on. There we go. So we have this kind of a thing, and now we want to, there's a top command. So we want to do top 10 by which column? The count column. There we go. And we don't actually need the count column anymore. It's served its purpose, so I'm just going to project username. There we go. We got the list that we're looking for. So let's put a semicolon on that and save it in a variable, and then move on to the second part of the query. We're going to go back into the same table. I'm not saying this is the most efficient way of doing this. I'm just showing you how it's possible, right, to produce a smaller table and then reference that later. So these are fake tables, so sometimes the examples that are possible are kind of limiting. But so we're going to say where result is not equal to successful login again, and username is in the top 10 failed users. But this, you see, it gives you an error. That's because you need to put it in parentheses. I don't know why, but you need to do that. And then we can say, and let's just grab, I'm afraid to just, let's limit. Yeah, let's grab 500 at most of these. I'm just curious. Oh, only 169, okay. So let's fix the timestamp again. And now let's summarize count. This is going to be the time series call to summarize. So this is going to be timestamp 1 minute, but we're going to have this business after. So this is where we're saying bin all of the records, as I explained before, into these bins, and then calculate this average function once for each bin, and yeah, and I guess it's like calculate this function for each unique combination of bin value and username. So what's a unique combination of bin value and username? I will show you. So a unique combination of bin value and username is this. So 2022, January 3rd, 725, Roe Campbell. That is a unique combination of this, and that's why I produce a count here. So let's produce let's do a different chart. We'll do a column chart, and let's see what we get. So not particularly interesting. This is kind of a contrived example, but it shows a few important things. After the by clause, we specify a comma and then username. That would seem to suggest that we could keep expanding that list of columns to include more than just username. In that case, the meaning you're trying to write into your query would be something like, for each time range bin, calculate the statistical functions once for each unique combination of the following list of columns, username, etc. But you'll find support after the bin function is limited to specifying only one column. And that might frustrate you, but this is not necessarily a shortcoming of KQL. Other languages have a similar limitation. It does not follow that the meaning you're trying to imbue your query with is impossible. It just means that you need to take a slightly different approach to work around this limitation. So the key to working around this limitation when building time series is concatenation. At first, it may feel like a cheesy trick, but in time it will become a key part of your behavioral analysis arsenal if you're weird like me. So in this approach, whichever list of columns you want a unique combination of to produce a new round of statistical calculations in each time range bin, you just concatenate those columns into a single string and store that string in a new column, and that new column becomes the column you specify after the column to bin. As an example, let's say in the above query, that's this right here, after running it, you realize you wanted not unique combinations of users, but unique combinations of users and their password hash. And actually this produces a lot of combinations, so to stay under the recommended limit in Data Explorer, I'm going to change this earlier call to top to produce 5 users instead of 10. But other than that, this is going to be a very similar approach. So what we're going to do is we're going to modify, and I'm just going to actually copy this and paste this down here so we can go back up to the other one in case we make a mistake. So after fixing the timestamp, we're going to have an additional thing here. We're going to create a new column called username underscore. You can call it whatever you want. I'm just going to call it password hash. And then we're going to use the strcat function. And this can all go on one line, but I'm going to actually put it on multiple lines for those that are at home, on phones maybe or something. So username and password hash. So this is a list of 3 strings. This is a literal string that you're just providing here in your query. These are referencing the strings stored in these columns, and it's going to concatenate them in these 3 into a single string in the order that you provided. And it's going to store that in this. Now we need to change the bin thing here to say like this, and we should be ready. And there we have it, unique combination. So as I said, first comes the username and then this little space and dash. I put that in there to make things easier to read. And then you have these. This is the password hash. So maybe fictional, but these types of time charts, you know, they can help you spot anomalies is where I'm going with this. And sometimes just, you know, the columns that you get by default in your table, they're not enough. You need to you need other unique combinations. This is how you do that. So these types of time charts so far have focused on visualizing and summarizing data over time from one point in history to another. The form of the output table and shape of the output graph, they bear a direct resemblance to the input table. So for example, if the earliest records timestamp in the input table was 2 weeks ago and the latest records timestamp was 1 week ago, then the time chart spans that time range in history exactly, from 2 weeks ago to 1 week ago. And sometimes that time chart does not quite scratch the itch you have in the anomaly hunting department. Sometimes there is a seasonality to the phenomena that you want to understand more. Maybe because there was no Sherlock around who was able to crack the case the first go round, then the problem keeps happening. So I want to give you one more tool for such occasions. This approach involves constructing custom time range bin labels for your records. The type of label you'll create doesn't help you understand which slice of overall chronological time in history a record occupies, but rather it helps you understand which recurring slice of chronological time a record occupies. This is the difference between knowing that event X occurred at 7:13 a.m. on Tuesday, the 23rd of January, 2024, and knowing that event X occurred at 7:13 a.m. on some Tuesday in history, but which Tuesday exactly is not known. So humans often schedule things that repeat on an hourly or daily or weekly or monthly basis. You might want to know, for example, is there a trend as far as which hour of the day or which hour of the week that a particular phenomenon is happening. I believe when the aggregation function which you're using in each bin is the count function, then this may be considered a form of histogram. However, I would encourage you to experiment with other aggregation functions using this approach as well to see what trends you can find. For instance, percentiles, you'd be really surprised what you can find, especially with some of the interesting data sets you'll find out in the wild. So before we consider an example, we need to iron out the details of making custom time range bin labels. So one key to constructing custom time bin field values is to ensure their lexicographic order is the same as their chronological order. This is so that when a list of these bin field values is sorted using common lexical sorting techniques, like those in the table user interface here, right? Or via KQL sort function, or even in a spreadsheet program. This is so that they're in chronological order for displaying on a graph. And commonly this involves ensuring that numbers are all a fixed width in terms of characters, digits, regardless of magnitude. Padding them with zeros on the left side is needed. So what does that mean? If you're having trouble imagining, if the smallest number that you could have is if the range of numbers is 0 to 99, then you would want to make sure that they're all padded, right? All the way to 99, okay? As opposed to, 1, 2, 3 to 99, okay? Because the reason for this is that if the largest number in your group is 100, then consider the number 9. So 9 is less than 100 in a logical ordering according to magnitude, but in a lexicographic or alphabetic ordering, 100 comes first. So to fix this, you pad the 9 with 2 zeros on the left, and now both orderings will be the same, okay? So many languages have a function for padding strings on left or right, but I didn't see one in KQL, so we're going to construct a user-defined function for these scalar operations. So we're going to call this function pad string left. We're going to set it equal to, this is the function. It's going to follow this syntax. First is between the parentheses the list of arguments. I'm going to write them vertically, but you don't have to. I'm going to call it str string pad char string min length int. All right, these are going to be the arguments to our function for padding these strings. And this is the body of the function. So the first thing is we're going to create a variable called ch. We're going to set it equal to the result of this if function. And what is the if condition? Well, we're going to compare the length of this pad char. So we're going to say strlen. It's going to give us the length of the pad char. If it's less than 1, so we're trying to detect the empty string, then we're going to put 0 if they give us an empty string or if we accidentally do that. Otherwise, we're going to take the substring of pad char 0 through 1. This is so that if someone gives us a pad character, which is greater than 1, say it's 2 or 3 or more characters, we only grab the first character because this makes the math easier, right? So we don't have to consider, it doesn't make the math more difficult if we're trying to pad things with strings that are, I'm just trying to say this is a way to make sure that it's actually just a 1 character long. And okay, so now we need another if condition. In this case, I'm going to say if, what are we going to compare first? We're going to call strlen again, but this time we're going to do it to the str, the actual string. And we're going to say if it's greater than or equal to the min length, then we're gravy, and we can just use the string, return the string, and it's like it wasn't needed to even call this function. Otherwise, we're going to need to actually do the padding, and we're going to use the strcat function to do the padding. So first, we're going to concatenate on the left side, because this is the pad left function. We're going to pad it on the left with the value of the padding. So this would be like, if we're going from 9 and we're trying to go to 009, then the first argument to this strcat function needs to be this string. Okay, so how do we do that? Well, we can first repeat the character. And actually, let me go back. That gives a good description. It generates a dynamic array containing a series comprised of repeated numbers. So I'm going to repeat ch. That's the character we arrived on earlier. Oops. Not count, ch. There we go. Min length minus strlen of str. This tells us how many of these we need. This produces an array, though. We can't concatenate an array onto a string. We need to convert this array of characters. So right now it's a list of how many zeros. So instead of this string, it's this. Okay, it's like an array of like 0, 0, or an array of these strings. We need to convert this into this. All right. So how do we do that? I'm going to delete this down here. That's what this thing called strcat array is. So you just give it the array is the first argument, and this is the string that you want to join these elements with. I'm giving it an empty string because I don't want anything in between the zeros or whatever character we pass in here. Okay. And then finally, we're going to have the string that we arrived on, and also concatenated. So let's review this. str, this is the string to pad. Naturally, this function is probably going to be used with numbers, so this just means to use this function, you must cast your numerical values to string first. And the pad char, this is the character intended to be used for padding on the left-hand side of the string. You pass in a string that should be one character long, but if not, it will be truncated or coerced to a default value of 0. And the min length, this number refers to the minimum length of the string to output. So typically here you will input the length of the longest string in your set of number strings. So if the max number is 1,000, then the string 1,000 is 4 characters or digits long, so 4 will be this argument. Inside the UDF body, the assignment expression let ch equal, and then the if expression, it does what I described above. It checks if the pad character string is the empty string with length of 0, and if so, it gives default value of 0. Otherwise, we grab the first character from the specified pad character string using the substring function, just in case it's longer than one character. The remaining if call produces the ultimate value returned from the function, our padded string. We check if the length of str is already greater than or equal to the minimum length. If so, we just return the value of str as it is already. Otherwise, we need to produce a properly padded version of the string. And there are a few layers to producing the padded string. The outer str cat call has 2 arguments to concatenate. The pad string, for example, when making 009 from 9, the pad string is 00, and then the original input string, when making 009 from 9, this is 9. So to produce the pad string, we use the repeat function to generate an array where each element is the pad character, ch, that we derived earlier, and where the length of the array is the difference between the minimum length and the length of the string that needs padding. Then we take this array and concatenate all of its values with an empty string delimiter into a single string using the strcat array function. So we're going to test this now. On the next line, we can make a test call to true to our example with 9s. We'll make 4 of these. I think, do I need a semicolon? Guess I do. Would you look at that? However many of these. If I put 1, look at that. Holy smokes, right? So that is a user-defined function. So now that we can pad numbers, let's consider an example. Let's convert an earlier time series query that we made to this format. So let's look for the top 10 failed users. I'm going to grab this and copy it. Okay, so we still have the top 5. I could rename that, but that's okay. Result not equal to successful login, and username top 10 failed users. Timestamp to date time. We're creating the username password hash concatenated string. And after this, we want to create our timestamp parts. So this is going to be the timestamp hour. We'll use a function called datetime_part. Specify the part that we want as the hour, and we'll give it the timestamp. Now we want the weekday. Hour gives you the hour of the day. Weekday gives you the day of the week. Now for weekday, you can't use this datetime_part function. There's a separate one called day of week. Okay. And now we're ready to create a custom bin label. I'll call it custom bin label equals, and we're going to do some concatenating again. The first part is going to be the weekday. We have to use this syntax, which I'll explain in a minute. So our custom bin label values each represent one of that's these values down here. They each represent, and let me show you the table. Each of these represent one of the possible 168 hours of the week. We create this new field for each record by first extracting the parts using the datetime_part function and the day of week function. So there's actually a website where you can see the different possible values. This function allows you to take, as you can see, year, quarter, month, week of year, day, hour, minute, second. It just does not have day of the week. That's a separate function. So next we concatenate those two fields into a single string, and I'm giving it a kind of a delimiter in between here just to make it visually easier to read. I arbitrarily chose this. You can do whatever you want or skip that part. When you concatenate the values, we pad the hour values first, right, by using the pad string left function that we made. And the day of the week value, it has to be converted to an integer and divided by a single increment of its unit, which is 1 day, to give us a number rather than the range that were originally given by the day of the week function. So finally, we replace our call to the bin function with our custom bin label. And then we also perform one last sort. That's to make sure that this table is sorted by this value, otherwise it might not be. And then we render a column chart. So This shows us trends, right? It doesn't matter which, for example, I'm noticing in the hours of 10, 11, and 12 on the third day of the week seems to have a lot of these compared to other time periods. I might ask what's happening at that time, but this is just a fictional data set, so um, this is maybe there's no real conclusions we can draw here from this, but in real situations, this is the kind of time chart that might help you because you could run this query over a time period of many, many weeks, even 6 months or a year or many years, and notice patterns. And we're just counting, but you could do averages or percentiles, and you could notice trends about things certain in a particular um, season, right? That's what I would call each of these values. It's like a season that recurs. So remember this tool because there are certain situations where a normal time chart won't help you. All right, so the next part that we're going to talk about is parsing JSON. At the time I'm making this, JSON is pretty ubiquitous. I assume you've been exposed to it, but if not, it's just a text-based file format used for many purposes. Given how common it is, it's pretty handy that KQL comes with functions out of the box for parsing JSON encoded data into KQL fields. But truthfully, a lot of tools have it nowadays. Since KQL some circumstances, I believe based on ingestion settings, it automatically parses JSON fields into the dynamic type. I'm going to provide a fake data table of JSON strings for us to parse. So let me copy that. And it's called computers. And so for this, you don't need to be in any particular database here. I'm going to run this. So you can see by the data type that these are all actually strings, which means that this, as long as I've created valid JSON, we can use JSON parsing functions, right? It only has one column, all right, and that's this single string called JSON. Don't let this confuse you, right? It's not a special data type. This is the name of the column. The data type is string. So I'm asserting to you that the format of each of these strings is the JSON format, which would mean that if it's true, we could use and spoiler alert, it's valid JSON. We can use JSON parsing functions on it. So it has a lot of different fields encoded. And we would like to pull them out into separate columns so we can do table things with them, like calculate statistics. We're not going to use regex alone to pull these values out into columns because KQL has dedicated functions for JSON parsing out of the box. So So now it looks the same to you in this view, but if you go here, you can see it still kind of looks the same, but it's put these on a different line. And if you're like, I still don't understand what the difference is, let's call get schema again so you can see. All right, so you can see parsed is system.object type. It's a dynamic type, or maybe not a dynamic type. It's called a system object. So now it's like a hash table, right? Which means we can reference the individual the individual fields that it's extracted and that are nested in that JSON, sorry, the parsed column. Now, I would say we're not done parsing because some of these values are, there's still multiple types of values in some of these fields, and we would like to maybe do some proper statistics. Because maybe we're the type of nerd that, you know, in this, let's say this is our ultimate tabular format, and I can show you how to pull these out. You probably have an inkling how to do it with the project command, or extend or whatever. But I mean, that aside, even if you're presented with a table like that, you may be asked, right? You might be the super nerd, but they ask to come in here and they're like, well, we want to be able to sort these by, like, you know, storage or RAM values or something like that. So let's pull out some of these values that are nested in these nested fields inside parsed. And also, while we're doing that, on some of them, we're going to also run a regex commands in order to extract things a little further. So I'm going to call project. The first thing we're going to do is put ID into, and I'm going to call toInt. Like that. All right, great. Next one is brand. I don't think there's anything we need to pull out of that further, so I'm just going to call toString. Okay. Same with model. I'm just going to pull that out into its own string column. Okay, CPU. I'm going to call this CPU specs. We're going to pull out the details into their own columns. So we're going to have multiple extractions. So our pattern will be on the first line. And I'm going to put toString on the second line, just to make sure it's actually a string. And this is our input field that we're running the regex over. This is going to be a fully anchored pattern. We're going to describe this string from beginning to end. So the first part that we want to capture, I want to capture the prefix of this core word. So there's a lot of ways that you can do this, but I'm just going to do it this way. I'm going to pretend that this table is not only like 20 records long and that it has, like, you know, a zillion records, and I'm not confident in, I'm not very confident in my understanding of the type of language we might find in it, so I want to be a little bit permissive. Okay, so we're going to match lowercase or uppercase quad, and then we're going to do some alternation. We're also going to support hexa. All right, next one we'll support, this is the last one for that part, which is octa. Uppercase or lowercase. So this is our first capturing group. After that, is that really it? So we have quad, hexa, octa. Okay, I guess that's really it. So now we need to match the word core, as I understand it. I'm going to allow it to be uppercase or lowercase. I'm just pretending that I need this to be more permissive. Then we're going to match a space character after that because there tends to be a space. Or it seems there's always a space after that. And then, you know, maybe I'll do even more permissive. I'll do 0 or more allowed spaces. Then I want to capture a number for the Hertz rating. So I'm going to do 1 or more digits, and I have to, in this type of string, I have to escape the backslash. So that's why I have 2 there. So 1 or more digits, and then a literal dot character, maybe, and then 0 or more digits. That's how I'm going to match this pattern. Again, I'm just pretending that maybe there's more values in here than there really are, just to be permissive. And these are all gigahertz rating, and I'm going to not be very permissive on that. I'm just going to only allow gigahertz because I assume all machines that our company deals with maybe are operating in gigahertz. Okay, so I think that's correct. I guess we'll find out. Um, the next thing is going to be the RAM right here. This is going to be some regex too, but it'll be a lot less complicated. So we're just going to extract one thing. So this will be our pattern. We're going to capture the first capturing group. By the way, if you're like, how do you know what number to put here? I went over it before, and you know that the 0 refers to the entire match string, even outside the capturing groups. So if your question is, how do you know what number after 0 to put here? Just think of it this way. You have like nested capturing groups. It gets complicated, right? But this number is maybe you're reusing a pattern. This number is going to refer to the start of, these are numbered based on the order of the left parenthesis, right? So if I put a 1, it's going to do this group. If I do a 2, it's going to do, I'm confusing myself. I think that's right. If I do 3, it's going to be like this one. At least I'm pretty sure that's how that works. Anyways, so toString, and this is, what is the name of the column? It's just RAM, right? Yeah. Parsed.ram. Okay. Now we need to actually write the pattern, not so fast. Fully anchored, again, I'm going to have one capturing group at the beginning that captures 0 through 9, 1 or more, and that's it for the capturing group. After that, even though it's different meanings technically, I'm going to support uppercase or lowercase gigabytes. All right, next we'll do storage. This one's a little more complicated, not as complicated as the CPU specs. Extract all. Here's the pattern and the reference to the input. parsed string, parsed storage. This one's also fully anchored. So first we want to, and let me see, it's kind of hard for me to, let me put it down here. Here's an example. I'll highlight this. Okay, so the first thing we want is the number. Then we're going to do basically this, except I'm going to change it a little bit. Some of it might be in terabytes, so I'm going to support doing it that way. Then a space, then another capturing group, and this will be drive type. So this one, I'm going to be a little bit permissive. One or more of which characters? Let's do uppercase letters, lowercase letters, numbers, underscores, periods, and hyphens. And that'll be it for that one. Okay. Graphics. This one, we're not going to do regex. Some of you breathe a sigh of relief. And the last one, price dollars. We're going to do just a single extraction pattern. We're going to extract the first capturing group. Okay. Pattern. This is going to be fully anchored. Let me grab an example of the price there. So probably not going to capture the dollar sign. I'm just going to assume people know. And then everything after that I do want though. So basically I'm just getting rid of this. So you don't even need regex to do this, but you know, I'm just going to use regex to do it this way, to rip off the dollar sign. All right. So basically, let's run this first and see if we were successful. Wow, would you look at that? We are. That's beautiful to see. So where are we going with this regex business? Well, some of the values in those strings are numerical values, right? Like RAM/GB. And we might want to sort the table of computers by some of them, some of those values. And so we can, some of these are still nested though. So we can, maybe I'm thinking, let's project this table once again and extract some of these. For example, CPU cores. Right now we just have the text, quad, hexa, octa. I'm thinking we're gonna be a little more tricky than that. We're gonna do a case statement, which is like if else, right? So first we're gonna go into the CPU specs. And if you notice, it's in like a nested array. Again, that goes back to the capturing group business. So we need the 0. So this is the, I wish they would give us more room. Oh, look at that. Okay, so in this outer array, there's one element, that's this whole array. So that's the 0th element. So 0. And then which one do we want on the inside? We want the first one, which is also the 0th element. So that's, I'm sorry, I typed something different. There we go. And we're going to say case insensitively equal to quad. Then we'll say, then we'll give the value, we'll assign the value 4 to CPU cores. So this is the pattern of what we're going to do. We're going to do this a few times. All right, and hexa, an octa. We just got to change these numbers here, and we're gravy. Okay, and then we'll give it a default case, which is -1. So CPU hertz. We're gonna, yeah. So like I shared before, this is the hertz value that we extracted, if you remember. Um, well, let's make that a number because I don't think that's it. Yeah, it's a string right now. We don't want that. I'm gonna call it. Remember, we only accept gigahertz. Okay, CPU specs 0, 1. Now that's a double. Storage size. So that's going to be this first thing right here, this first number. We're going to convert it to an integer. So that's storage 0, 0. And then we're going to also have a storage unit, which is equal to storage 0, 1. And storage type equals storage 0, 2. Let's see what we have. There we go. That's a lot better. Look at that. We have proper values in this table now. So what I'm going to do is I'm going to force the storage size to always be in gigabytes. So that means the cases where you have terabytes, we're going to change it. So I'm going to say storage GB equals, and another case statement. So if storage unit is equal to GB, then we can just keep the same storage size. If not, we're going to multiply. Do you remember off the top of your head how to convert gigabytes into terabytes? It's times 1,000. So then we're going to have that. And now we have some extra columns here. We don't actually need the store, in my opinion. I mean, depending on your use case. Project away storage size and storage unit. I'm just going to get rid of those. All right. So that's better. I like this form of the table. And I know this became about more than just JSON parsing, but you see all the stuff that we could do now that we couldn't otherwise do without the parsing step. I mean, we couldn't have done it unless we wanted to get a lot more complicated with the regex and parsing logic. So sometimes the data in KQL tables changes. Some developer you haven't met made a change, and now your query is broken because the table records are different. So let's change this. So this is a different table payload. All right. Oops. There we go. Oh, query broke. So even after you parse the JSON, most of the data is still inside a single string. I can show you that. Interesting, right? So this is nested JSON. It means after an object was serialized to JSON, and how that works, I mean, This goes back to, I guess it shouldn't be your first programming language, like I said, but you'll have an in-memory data structure like a hash table or an array, and then when you, it's called marshalling or serializing, you convert it to a JSON formatted string instead of a dynamic in-memory object. Just becomes as all that data is encoded into a string that follows the JSON format. So it means, if in cases like this where it's nested, it means after an object was serialized to JSON, that's this inner one, the developer assigned that JSON string to a field inside a different object. And then that other object was serialized to JSON. So it seems like, what are you going to do? But it's no big deal. You just, um, first of all, put skew in its own column, just to make that separate. And then you just run the parser again. All right, so let's run that. And now you have a nested object again, kind of like what we had earlier. So do you see how it seems like there is an extra call to toString that I put in here? That has to happen because some parse JSON requires a string as input at that point in the pipeline. And at that point in the pipeline, the data field is a dynamic type. And you could verify that with getType, but that's why I have that toString call. So now that we did this, this whole thing can just be inserted before the rest of the query, the old query that we had, right? So just to make it work just like it used to work, thanks to our choice of column names. See, I call this shimming the old query, although there's probably already a term for this that someone else came up with. But it's just where you take your table, which has changed, and you don't want to re-engineer your whole query. So you just insert some logic early in the query to make the table fit the old query. That's a handy technique. It allows you to preserve the intentions of a previous query author without necessarily inserting your own opinions. So only a slight modification must be made to allow the skew to persist to the final table. You'll notice the skew isn't actually in the output. We have to continue projecting that through the rest of our operations. Otherwise, we'll lose it. So I'm just going to add that here. And now we have the skew. And if you notice, there are duplicate skews in there due to I was being funny when I made this. So that's JSON parsing. Now, there are many developers you may encounter out in the wild who don't have an overly refined sense of when they are departing from the safer realms of well-defined grammatically correct file formats. And this isn't a dig on those people. They just often have other priorities. They have other priorities, other projects. Their projects have to fit a kind of particular mold and culture. So the consequences of this is you may find the data you're looking for is encapsulated within a file format that doesn't have a ready-made parser for you within KQL. This also goes back to, not every process in the world is collaborative and cooperative, right? Sometimes, even in situations where expecting people to be cooperative, they're not. So when that happens, you'll have to somehow compose a parsing routine in order to extract the data in question into columns. So I'm going to give you an example of this. And this example, it's admittedly contrived, but it is a perfect example, a perfect hypothetical example of the kind of grammatically ill-defined language you might encounter in the wild. It would be perfect for us all, I know, with logging formats or in perfectly tabular formats, but the real world is dirtier than that. This lesson is about not letting unusual types of string encoding and logging formats get in the way of your quest to comprehend data in a statistically valid way. So I'm going to show you the data table. I'm going to call it loony logs. All right. You can see they're different, very different lengths. So did I put this all on the same line? I'm going to put this on a new line. So if you're looking at this and you might be tempted to try to write a master regex pattern, to try and just, you're like, I'm going to extract everything in one shot. So not so fast. I'm going to stop you right there. Part of being a good regex user is knowing its limits. Even if it were possible, given the limited nature of this particular example I'm giving you, just imagine this table had 40 million records in it instead, or hundreds of millions of records. In such situations, it is kind of commonplace to encounter bizarre edge cases. So I submit to you that it's good to be able to use regex, and we definitely will, but it's also just as important to use standard parsing features when they're already available. That's one of the advantages of working with a valid enterprise product like KQL. So before we start coding, I'll give you one more look at this monstrosity that I concocted in a smattering of scripting languages and with ChatGPT. It's crazy, right? So it's a lot of text. So I just assigned it to a variable called loony logs. So, just to hint that as you're doing this, you could just refer to the table name, or you can just pipe this table to your commands too. Also, this is kind of an eyesore, It's true to the situations you might find yourself in out in the wilds of computing. I'm not going to provide you with a formal grammar describing this, but I will kind of give you an informal description of the language in these strings or documents. So the first thing I notice is there, and I'm just going to pretend this is my first encounter, but I invented this, so it's not my first encounter. There's some kind of a rudimentary label with a computer name at the start of each string. And each of these seems to be terminated by a semicolon. After this, there's some XML. The outermost element is called batches, and its closing tag is at the very end of the string in every case. Inside batches, it seems to have one batch. Some of these look like they have multiple batches though. So one or more inner batch elements. Looks like inside of each batch element, there's some kind of a JSON document. And these contain two keys, one duration, MS, and then a payload. The payload string, so like the duration is a number, the payload is a string, and it seems to have like user info in it, a seemingly random number of user records per string, um, and it may be like YAML, just a hint there. So we have our work cut out for us. We're gonna parse the info out of these strings into a beautiful little table. And if you're coding along at home and you don't want the answer spoiled, now is the time to pause and try it out yourself before we proceed. So the first thing I'm going to do is give this a, let's, um, no, not get type. What am I going to do? I'm going to extend the table. I'm going to give each of these documents its own ID. All right. So what does that mean? You can see each has a random GUID now. The reason I'm doing that is because I'm not sure if it's ultimately important to logically associate the final rows in the table, the rows and columns and data points that we're creating. I'm not sure if it's important to logically associate them with which of these rows up here in the data table they came from. And since there is no ID, I'm just creating one, all right? If you hadn't heard of it before, a GUID, it's a globally unique ID, which is like a really large random value that you can use as an ID. It has a very, very extremely low risk of accidentally repeating the number. Most languages and platforms have a way of making these. You could also take like a hash of these, but that's less interesting idea to me at this point. So, yeah. So first, the computer name. This label here at the beginning. Let's use some regex to get that up. So we're only extracting one value. Will be the first capturing group, and it's going to be from the doc column, the doc string, and it's going to be not a fully anchored regex. This is going to start at the beginning. This pattern, I'm going to say it can start with a lowercase or uppercase, just pretending to be permissive, even though we know that they all start with lowercase. I'm going to allow 0 or more space characters, an equal sign, 0 or more space characters. The capturing group, what do we want to capture? That's the computer name, which is 1 or more characters long. And how do we know? I mean, it's letters and numbers, but if you want to be a little bit lazy and extremely permissive, I'm just going to say, I'm going to use a negative capturing group. I'm going to say it's anything except for a semicolon, 1 or more of those, and then after there's a semicolon, and then 0 or more spaces. Let's run that and see. Looks like that was successful. Next, we want to extract the XML document. So I'm going to reuse the regex pattern that we had here and just extend it a little bit. Technically, we could use a single regex pattern. I know that's true, but I'm just pretending that this is my first encounter with the table. In those situations, you're not fully optimized. You're just keeping things a little sketchy. It's okay to repeat yourself a little bit. And you can always tidy up and optimize later. So in this version, I also need the extend command. We're going to put our additional capture group over here. I'm going to remove this aspect of the capturing, even though we could, I guess this is maybe a good situation. I could demo this. All right. So how are we going to capture the XML document? You're like, oh my gosh, this is crazy. We have to support so many characters like these and you know. It's actually really easy. We're just going to say any white space. We want literally the rest of the string, so it doesn't matter anything. Any white space character or any non-white space character. Remember I showed you this convention. One or more of those all the way to the end of the string. So let's see if that worked. There we go. So this business, I wasn't speaking completely hypothetically off the top of my head. I was right. This lets us extract the XML document. So I'm going to project away this stuff. No, I'm just going to project what we need, which is the doc ID, computer name, and the XML document. We don't need any of the other stuff now. So you can see this thing is starting to look a lot better. And anything else I need to explain about this? This is all syntax we covered before. Again, this type of string, that's backslashes are escape characters, so I need to do 2 of them. I don't think there's anything else about this that I need to explain. So we're ready to try and parse the XML, but we're not going to write a custom parsing routine because KQL already has that functionality out of the box. Just like they have a parse JSON, there's a parse XML. Not every language has this, so the fact that it has it means you should use it. All right, let's see what that looks like. Look at that, parsed XML. Fly this out a little bit down here. So it gives us this object. Let's take an example of one that maybe has more. Right here, this one. So parsed XML becomes a thing that has a inner batches element. The inner batches element has a batch field, and the batch field became an array. So this is like a data structure now. I mean, I say data structure, but of course I mean that in the more colloquial sense of a hodgepodge of hash tables and arrays. We can see batches and batch. It looks like the parser consolidated the cases of multiple batch elements into a single key called batch, holding an array where each element is the inner content from one of the batch elements, which is a JSON string. So that makes these batch elements what is known as a multi-valued field, since that field in a given single record can self-contain multiple values. So how do we cope with this? At this point, the way forward is going to be to split these records based on that multi-value field. And how that basically works is a record with n values in its multi-valued field will be cloned, and I use that word loosely. We don't want to assume too much about what KQL does under the hood, but the record has n values, its multi-valued field will be cloned. So there are n copies of it in the table. Each of the n records will be given one of the values from that multi-valued field. So before I go on, if that was confusing to you, I'm going to say, let's say this is record A, and it has, here's your MV field, okay, and here's MV for multi-value 1, multi-value 2, multi-value 3, and let's say that this thing has another field that's not a multi-value field. We'll call it solo field, and it has a solo value, okay? So where I'm going with this is that we need to split this right into three records. So when we undergoes this process, record A is going to be made into these records. All right. Um, so we'll say one, let's say after split. So record A1, autocomplete with this is monstrous, isn't it? Record A2 and record A3. So all of these are going to have the solo field. I mean, that's just true. But the multi-value field, now it's going to be different, right? Each of these is going to get like one of these. And maybe call it something else, but you get what I mean. So this is what I mean by splitting things out. We're going to split these things out based on these. So I hope that makes sense. Instead of continuing hypothetically, I'm just going to do it, and then you can run this before and after to see the difference. So the command we're going to use is, oh, you can see it says right here, expands multi-value dynamic arrays or property bags into multiple records. So this is a command. We're going to call, say JSON document equals parsed XML dot batches dot batch to type of string. You run that. All right. So you can see that JSON document is the name of a new column, and we're assigning to it this reference to the multi-valued field parsed XML batches batch. And just to be clear, after this multi-value field is expanded, we want the resulting type stored in the JSON document column to be a string. And you can see now some of these doc IDs, which were originally unique, have repeats. Because, as I said, these records were cloned. So let's, at this point in the pipeline, give each of these records an ID to differentiate which batch element any further data came from in case we need to split out any more of the data into more multi-valued field clone things. That's foreshadowing for you there. That's where we're going next. So I'm going to call this batch ID. Perfect. Now each of these are unique. Each of these are no longer unique. But where we're going is even these may no longer all be unique as we continue to split up further details. I'm going to declutter this because there's a lot to look at now. We don't need everything. So I'm going to there we go. That's a lot better. So now we have to pull values out of the JSON. And again, are we going to use custom regex-based parsing logic to pull the key value pairs out of the JSON strings? No, we are not doing that, mainly because KQL already has off-the-shelf JSON parsing functions, similar to the XML one we just used. So I'm going to say extend parsed JSON equals parse JSON, JSON document. So now let's take a look at parse JSON. There we go. Now we're going to pull these two into their own fields. Perfect. So now we pulled out the two fields from each JSON string into their own columns, and we're in the home stretch. So I earlier was talking about the payload column, and I mentioned it seems to contain what we earlier surmised to be sets of YAML formatted records. And it feels like we're going to need to separate these records this time without the help of a dedicated parsing function like we have for XML or JSON. You could create a user-defined function. I'm not going to do that. YAML is a complicated file format, even though we're only using a very simple subset of it, I think. There's probably a grammar for YAML, and we're not going to create like a spec compliant parser, but we are going to parse this data out using just kind of a little Baroque parsing logic that we're whipping up. So first I'm going to create an array because I'm noticing, right, there's multiple records separated by these new line characters. So I'm going to split these strings, this single string in each of these records, I'm going to split it on the new lines so that this is a string and this is a string and this is a string, and they're all in an array called lines. All right. Lines, there we go. Perfect. Now we're going to use a command that's similar to mvexpand, except it's called mvapply. This is similar, but we gain the ability to run a subquery. And here it says it returns the union of the results of all subqueries. So that's like, what does that mean? I mean, to me, it basically means we can reduce the number of records the original multi-value field is expanded into. So if this array has n strings in it, if we use mvexpand, it's going to expand it into, it's going to clone it and expand it into n records in the table. With mvapply in the subquery, we gain the ability to expand it into a number less than or equal to n. All right. In our case, we want one record returned for each logical record in the YAML string. A logical record in the YAML string comprises 3 lines or 3 slots in the lines array. In this example, it would be, here's a record. Here's a record. We may not know how many records are in each YAML string or each array necessarily, but it's a safe bet that the line count of all of the records will be a multiple of 3. And I think if you went through this table and you counted how many entries there are in each lines array, you will find they will be a multiple of 3. So if we have n lines, we want to split the multi-valued field into n divided by 3 records, where each record has a new column containing one of the starting indices of the records in the YAML string. Maybe that's a little bit farther. Let me just show you here. So with item index equals index, this means there's going to be an index column in the available to us within the subquery that tells us which index in this lines array we're on. I'm going to say record indexes equals lines on. Record indexes is going to be the name of the new column. I believe, maybe not. See, this gets confusing. So here in the subquery, I'm going to do some filtering. As I said, we only want multiples of 3. I'm going to say index mod 3 equals 0. What's mod? This is modular arithmetic. This is the modulus operator. It means return the remainder of integer division. So we're saying if you divide the index, that's the index of whichever element this subquery is on. The subquery is running once for each value in this array. And we're saying the index of the current item that we're on, if it's divisible by 3, if it's divisible by 3, that means that if you divide by 3 and take the remainder is 0. So that's what we're asserting. So that we only get 0, 3, 6, etc. So if that's true, we're gonna preserve those records. We're going to give that record a new field called record ID, and we're gonna project. We want the index and the record ID. Okay, now let's run this. And again, if you're confused, you just comment these things out or run these right before and after a particular command in the pipeline. So you can see we have index now, 0, 3, 6. The lines are still in here. We didn't pull out these values because they didn't want to yet, and we'll get into why. But you can see this is what I wanted to pull out, the index of a particular. So you can see, for instance, the John Doe one, we have 3 records. One for John Doe, that's 0. One for Jane Smith, that's 1. And one for Alex Brown, that's 2. So we have 0 times 1, which is 0. Sorry. We have, where I'm going is we have the index of the start of each record, right? 0 for John Doe, 3 for, I don't remember what the next one was, for Jane. Yeah, and for Alex Brown is the 6th index. And we have the record ID, which means the batch IDs are no longer unique. Okay, I hope I'm explaining that okay. So now we can use the index to target the appropriate slots in the lines array to extract the remaining values via regex. So I'm going to start with name. So I'm going to say extend name equals extract. You're like, whoa, I didn't realize we were ready for that yet. Well, we are. Extract, here's the pattern. We're going to extract the first capturing group. And we're going to, which one are we going to, what's the value that we're going for? Well, we're going to do it this way. So we're going to go and run the regex on the value in the lines array that has the value of index. At that index is what I mean. So, and if that confused you and you're like, boy, that's really confusing, you know what you can do? You can actually just, you don't have to jump straight to regex. You can actually just go like this, all right? And run this and see what it gives you, okay? So all I want, the point of the regex is just to extract the name and get rid of this business, all right? So just trying to give you the tools. I'm not necessarily, I know not everybody may understand this like right off the bat, and maybe that's part of my flaw as a teacher, but I just want to give you the tools to understand this if you really want to. So it seems like each of these start with a hyphen and then have a space and then the name, then a colon, and then I don't know how many spaces. And then, oh, we already have the ending anchor. And everything else until the end. All right. So I think this will look better. There we go. Now we have the names actually extracted. Nothing new was introduced in this regex pattern. It should be old hat to you by now. I'm just kidding. But it targets the string in the lines array, which can be accessed with the value in the index column. And we're going to extract the date of birth now, which is a similar process, except for we're going to do the subsequent index, or the subsequent slot in the lines array. I'm going to copy this because I'm lazy. Call this DOB. So subsequent slot in the lines array, it's +1 there. There's no hyphen on these. DOB. All right, and that should be it. So let's see if that worked. DOB. That did not work. I messed up. DOB might have multiple spaces at the beginning. That was my mistake. There we go. So now we have the date of birth. Email. Going to be very similar. I'm going to copy this. Except this is going to be the next index. I think that should be it for matching the email. Let's see. I'm on a roll. Look at that. Now we got the email out of there. So we literally have all of our columns now, but we're just going to clean the table up, project away the stuff we don't need. We don't need the JSON document anymore. We could have done this earlier, but parse JSON, payload, lines, and index. Look at that. This is the final version of the table. It's beautiful to behold. Do you remember the monstrosity that we started with? You're like, this is so cool. Wow, it's a table, dude. But do you remember what we started with? This craziness up here? This is a lot better. Now you can, now you can do statistics on this. All right? So this might not even be the ultimate end destination, right? I mean, there are a few criticisms you could make depending on what your goals are. So for one, I'm not saying to do this. I'm just saying, depending on what your goals are, the date, you can manipulate this. Maybe you need separate numerical values for years, months, and days, etc. So I leave that as an exercise for you, but this is just to explain to you, how to approach this challenge of coping with these weird formatted data sets, right? You still want to comprehend them in a statistically valid way. KQL gives you the tool to do that, not just the statistical side of it, but the multi-value fields and the language recognition tools in order to do that. So, believe it or not, this brings us to the end of my epic KQL crash course. Thank you if you made it this far. I just wanted to make this because I had a lot of teachers myself that were really inspiring, specifically on YouTube, over the years before I made the career switch to information technology. And I was really inspired by some of the people who selflessly gave away so much free content and knowledge. And so I just wanted to give back, right? And in my career, I've had the privilege of, working with tools like this. And so I was just inspired to give back. And so I just want to say thank you if you made it this far. And if this was useful to you, please a thumbs up or a like. You can follow me on LinkedIn. My name is Dave Vanderweel. So thank you very much for sticking with it. I hope this is useful to you. If you find any errors, just shut up about it. No, I'm joking. But seriously, thank you, and good luck to you. Bye for now.